Alrighty. So today we are getting right into it because I still haven't finished day 20, part 2. I've had time to think of it, and I have an approach I would like to take. It's basically the same one I discussed at the end of the stream yesterday. Um, and I'm not completely sure on correctness, but I think performance should probably be fine, and if not, there's room for that. So give me just a sec here. All right. Let's get into it. Where were we? Race condition. Previously, we could skip over one wall. Now we could skip over up to 20. Um, so, how I did part one was by taking a wall and then connecting the 2 points on either side of it, already knowing the cost of the distance of each point from the end, right? Then I would do math on that. And that is what you can see over here in this cheat method. And what I want to do is make a kind of generalized cheat method that does that, not just for that one point that's on the other side of the wall, but for any point that is within a certain distance. And that shouldn't be, well, I mean, it shouldn't just be any point. So it should, for one, be points that are cheaper, right? You should only try to get the shortcut to a cheaper point. And like formerly, we were avoiding these that were only touching this. I don't know what to call these points that are sticking out, right? Because cheating across this isn't worth much. So I also want to do that here, basically by filtering based on how much time it would save potentially, right? So we only want to search for points within this range that would actually save us enough time. Yeah. Now the one thing I wonder is, say, from here, I could cheat to this one. I could also cheat to this one, and they might both be good enough. But I wonder if they count as a same cheat, right? Because they have different end paths. Like there isn't a path all the way to here that uses walls. So that's what I'm not sure about on the correctness side. Like in my search, it might not be sufficient to find a point, but also make sure that there's a path to that point that's only walls that's within there. And I'm hoping that's not the case because that's what will get me. All right, so let's give that a shot. This bit here, I want to generalize. Let's pull that as a function. We'll call it time saving. F time saved to go from one point to another. And hold on. We are looking for anything that saves 50 picoseconds or more. All right. From point to point. And what's this? Heat map end position minus this whole bit. This whole bit was a time saved. Where 2, so A is the closer one, right? Yeah, A is the one with the shorter, that's closer to the start. And maybe I should insert that heat map from is less than heat map 2. Or maybe option. Yeesh, I can't type. Okay. So heat map A from, I shouldn't call this heat map. I should get that like an actual meaningful name too. plus just the Manhattan distance plus a dot dist to b. Okay, because we are adding this much time to walk through the walls. And right, this is a time that must be less than 20. This must be greater than 50. Okay, def cheatable. Okay, so from a point, or let's see, what do you want? We want points within 20. So we're gonna have let's have a list of points here. Maybe I make this a map. Maybe we cache this. Or not, if we're only using it once. I don't know what I'm doing here. Okay. So let's take the area around well surrounding equals area dot bounding. So I said just this point, and we're gonna expand that. So for the 2 picoseconds, we expand it twice, right? Now we're at 20 picoseconds. So we're gonna expand that 20 times. Okay. So now we take things on the path. Yeah. So path. Oh, I did do a little refactor of this post stream for calculating the path, just not doing it with a flood fill. So that code is more concise. But yeah, now we have a path, which is a list. So path, we're going to filter that's in the surrounding area. And then we're also going to filter well, I think we're just going to count. Dot count. Well, no, I think this is what all we want for this method. So we'll just do cheatable. And from that point, we count the ones that save enough time. So we can do path dot let's map. So for each start position, we take all the cheatable. I don't think we're gonna map to time saved. We're gonna count and such that time saved start end is greater than or equal to 50. And we can take the sum of all that. That's wait, is this really it? Well, adds 2 equals that. All right. So for part 1, that should be 32. So let's see if this gives us the correct answer. Oh, hold on. We have a stray A somewhere. From that list 2. Oh, right. We have a failed assertion. I think we should just calculate the time saved and then we're filtering it after. So we don't need this assert. We don't need to make it an option. Because the time saved might be negative, in which case we ignore it. $11.68, that's too many. That's too many. So we're gonna filter, we're gonna make this a filter. And then we're gonna search connected by walls, val connected by walls from point to point. Yeah, I knew it couldn't be that easy. This is no longer ans2. What do we call it? This is well, this wasn't really cheatable. This just maybe we just add this filter in here. And we'll continue to call it cheatable. So we're gonna do dot filter. And yeah, from this, I'm gonna call this P the start. Or the from. Let's call it the from. Time save from, whoops. So underscore is from, and this is 2. It's greater than or equal to 50. Okay, so these are candidates for doing the cheat. And then we check that they're connected by walls. So our ans2, make this a Boolean here. Our answer for part 2 is going to be all of these are cheatable, which is to say they are close enough to cheat to, and they will save us enough time. So for every potential start, yeah. For every potential start, we get everything that's close enough and everything that will save us enough time. And then we further verify that they're connected by walls, or we're going to count the ones that are connected by walls. Start cheatable, and this gets us all the end. We're going to count all the ends such that you're connected by walls, start to end. All right, and then we take the sum of that. How does that sound? Hey there, Soggy Boy. So for everything, we get this count, and then we sum. All right. Hey, everyone. Welcome. Michael, Hellhound. 10 minutes left. Okay. I'm doing part 2. And my approach is very simple, and I'm hoping it's not overly simplistic. But I had alluded to doing this when I ended stream yesterday. Yes, I got part 1. But I'll quickly say what my plan here is. So I'm basically just generalizing my first cheat option, right? My first cheat option was to take a wall and cut things between it. And I wasn't taking these walls here because it would only cut 4, right? So to generalize taking these 2 points, what I'm doing is taking any point within 20. So that's here. We take a surrounding. That's within 20, right? And we filter to make sure surrounding contains. And then we further filter that the time saved going from that point to the other point is going to be greater than or equal to 50. And that's not going to be the right answer, so I'm also going to further check that they are connected by walls, that I can do a search from that point to that point within the walls. Um, 8 minutes brute force. Okay. Well, I'm hoping that this is not sounding that brute forcey. Okay, we have a So these are the 2 points from 2. Okay, and yes, we have an implementation is missing, but we are compiling. What kind of search do we do here? I mean, it's just 20. We could just do a flood fill. Flood fill at most. Okay, here's my big question on this. Is let's say I start here, or I mean, let's say I start here cheating. I don't know. Let's say I start here and I end here. Those aren't connected completely by walls, right? But that still counts as a viable cheat. I mean, assuming it's yeah, I mean that's within 20 picoseconds. So is that one of the cheats we're looking for? Because those are not connected by walls. The thing I'm trying to avoid is counting this all the way to here as a distinct cheat, because I could have just cheated down to here. So this connected by walls is not the right thing. Let's just make it true and see what the answer is for part 1. I mean, for the example. Oh, wait. Not even. No, no. 1168. 1168 is too many. 1168. That is insane. Okay, let's just try cheatable from start pause. Oh, wait. From start pause. From the start pause, really? There are no cheatable points from there? Okay. Oh, no. We're adding up all the, are we adding up all the time saved? No. So we take everything surrounding the start position. Yes, I've done it the last 2 Fridays. I've just decided this is my Friday suit now. Oh no. Okay, so the surrounding area. Let's print that surrounding area. That's what. Surely that's big enough, right? That'll contain a lot of points. So we filter that points in the path in the surrounding area, and that they will save at least 50 nano picoseconds. I guess none of them will save 50. Oh no, I mean going straight to here will save 50 picoseconds. So cheatable should be giving us a lot. Okay, let's start pause. And let's do this. So area bounding start pause, and we expand that by 20. Okay. And then now we take everything on the path and we filter by that. So path.filter this area here dot contains. So this should give us some list of points. Yeah, I mean, basically every point should be contained within there, right? And then the last filter is at the time saved. So let's do a map on this to the time saved. So filter map time saved. Start pause to that point. Okay, right, there are a lot for which it's negative. And we filter that the time saved is greater than or equal to 50. Wait. Nope, that's a filter. Wait, really? None of those save? Oh, do I have it flipped? I have it flipped. That's why. Yeah, everything would save time. Time save from to 2. Yes. Okay. Let's just put a negative sign on this. Here we go. Here we go. Okay. So we do that. Great. So cheatable. There's the filter. Let's make that count. So 20 from there. Sure. Let's see what ANS2 is doing. 285. 285 is still too big. Right. And it's this problem here where I guess this cheating all the way to here is not being made distinct from this. Right. And I'm not sure about how to fix that bit. So, okay, I thought of an approach. I tried it. At least I implemented it. But maybe we don't get part 2 by midnight. Eric Wassel, good morning. Brett, Soggy Boy, Blue, Hellhound. Let's do this. It's sad. I so thought this would work. Wait. Save you at least 100 picoseconds. Let's just change this to 100 picoseconds. I'm going to try and answer. 100. Just try and put this in. And let's switch to the main problem. I want to check if performance is at least decent here. Okay. 2, 3, 4, 1, 5, 4, 9. Yeah, too high. Of course it's too high. Okay, so here's our input. Day 21.text get minus. Just go back to the calendar. 1 minute left. A Mario Kart visualization of yesterday's problem. I want to do visualization some year. When I get faster, then I'll end stream with a visualization. Um, 2024, 21. We'll just leave 30 seconds and do that. Michael, it might not be your Wi-Fi. We do have storms out here. Nope, it's your Wi-Fi, not mine. Okay, 3 seconds. Good luck. You teleport to the starship. The search party is missing. It can only be opened by physically typing on a numeric keypad. Great. Yeah, we have all these buttons. What does the input look like? What is this? The area outside is depressurized. The robot needs to be set inside. It can be told to push a specific button directly. Instead, a robotic arm that can be controlled remotely. So these are So to push a key, we have to control the robot. Okay, so this is the keypad for controlling the robot. Directional keypad has 2 rows of buttons. Gap up, A, left, down, right. So arrow keys. its robotic arm is pointed at the A button in the bottom right corner. After that, it can be used to maneuver. The remote control can be used to remove the robotic arm. Okay, what's the catch? This sounds simple. A button causes the robot to move forward, pressing the button in by the arm. Okay. So it can't extend its arm, it just walks into the button. Yeah, that's a lot to read. Um, so there are three shortest possible sequences of button presses that would cause a robot to type 029A. Okay. Right, so left, and there's up, left, and down. So we just do combinations. This is just binomial count. Unfortunately, the area containing the directional keypad remote. Okay. High levels radiation. Oh, wait, we've already read that. Arise at the keypad, the robot arm is pointed at a second different directional keypad. Oh, wait, no, we've already read that. Where are we? The area contains a third directional keypad remote control. Wait, there's a third one? Okay, I lost where I am in this problem. Oh. Oh, the directional keypad itself needs another robot. Let's point at the A button. A second a second set of arrow keys is used to control the robot, which controls the first robot. Okay. And yet again. Okay. Okay. There are many shortest possible sequences of directional keypad presses. And then the area containing this third is full of historians, so no robot can find a clear path there. Instead, you have to type the sequence yourself. Where you choose this sequence of button presses, here are all the buttons. In summary, one directional keypad that you are using, two that robots are using, and one numeric keypad. It is important to remember that robots are not designed for button pushing. In particular, if a robot arm is ever aimed at a gap where no button is present on the keypad, the robot will panic. So don't do that. So we aim at the keypad's A key. Okay. To unlock the door, 5 codes need to be typed on its numeric keypad. For each of these, there's a shortest sequence of buttons you can type to cause the desired code. All right. Okay. 5 minutes in, I think we understand the problem. Well, we understand the environment. What's the question? Find the shortest sequence of button presses necessary. And then we calculate the complexity. The length of the shortest sequence of button presses you need to type. Okay. And then the numeric code ignoring. Okay. Okay. Now to diminish the search space here, so let's consider that very first example where there are 2 ways to type this in the shortest way. Are the directions for both those ways? They're not going to have the same length. So we need to search from there. Because this, like, okay, going from A to 4, how many ways are it? Well, Let me think. We had Pascal's triangle, so this is 2, 1, 3, 3. This can be 6 minus 1 path, so 5. Like there are 5 ways to get to 4. We should just pre-compute that. So from A, there are 5 ways to get to 4, etc., etc. Okay, we can represent a keypad. I think we'll represent a keypad as a set of points. And I think we'll just pre-compute the number of ways to get from each point to any other given point. It's small enough that I don't need to do any like Pascal's triangle math. I can just pre-compute or cache memorize. Ditto for arrow keys. In fact, the arrow keys I could just do in my head. Yeah. And we could do this in our head, but we'll calculate that. So val mer keypad. So let's do a string, multi-line string here. Sure, something like that. No, we're gonna do that line down. I don't like what's going on here. Okay, we have 7, 8, 9. We have 4, 5, 6. We have 1, 2, 3. And then space 0A. Okay, this is the raw keypad. I guess we could split this at lines. Um, we'll call this a raw string. So val raw. And then we'll use that in our definition. So so we split into new lines, 2 character array, and then you just want points. You don't even need 2 character array. Let's just make this like 2 vector or something. And then area around the grid dot points iterator dot toSet. Okay. Oh wait, we want to make this a map. So given a point, yeah, this is exactly what we want to do. Except we can just say, you know, that. Okay, and this is a map from points to characters. If we invert that. Oh wait, we have to avoid a case. So let's make this a collect. Collect case P if grid P is not equal to space. And then in that case, we return P to grid P. Okay, and like maybe we want to invert that. I'm not sure yet. Okay, so given a key code, we want to calculate button sequence, keypad, numeric. What do we call this? So def numeric arrow sequence. So given let's just do like one character to another for now. So from character to character. And we'll do several options. We want the full options, not just the distance of the length of each of those options. But we do want the minimum. Right? So, so we have a list of sequences. Will be strings. You have a solution, but every solution hits the same wrong answer. Wow, you already have a solution. Jeez, people are fast. Sure, you'll have it soon. Okay. We can just do a flood fill-ish search. So def search. We're gonna have like a list of points and the path to get there. Okay. Two people are already solved part one. Okay. We've done this plenty of times. Let's just do like, what do we want out of here? We want a list. Only two people had the first star so far. Oh, okay. Wow. 15 minutes in. So tonight's is a problem. We're gonna be having fun for a while. Oh. Okay, so we're gonna have like we're gonna have a search. We're gonna have visiting, and each of those are gonna be a position and I guess a string. But maybe I should make those like a list of directions. I so feel like just brain farting right now. And yeah, we're gonna get like a list of directions. And I think my eventual output I want is a list of strings because we're gonna use those symbols here. Wait, visiting is gonna be a list set of these. Um, we're not gonna have a null case. So position, and we have a path onto the rest of them. Well, no, we just want the current position. So we want a point and then a list of directions. So position and then path. That's all we need. And we're looking for a character. So numeric keypad pause. Equals 2, the one we're trying to get to. And we turn off Copilot here. It's being a little bit annoying. Okay, we're all cursed to stay awake. Let's take it easy then. I'm not gonna rush things. I'm just gonna think things through. I want to make sure that I understand what I'm doing and that the code we're working with is nice. Maybe it's time to get a snack. How about that? 20 minutes in and 5 people. Okay, so we got our first one of those problems. Um, wait, what kind of a search are we doing here? Okay. I don't feel like I'm structuring this well. I'm just gonna copy like my day 18 flood fill. Okay. So we have, yeah, we have sets of points. I want to undo that factor. Give me 1 sec. Okay. Um, yeah, we could do this in that. Kind of just want to do this with a recursive function. Let's do it this way. Um, our end result is going to be a bunch of lists of directions. Let's have a previous ones we're visiting. So let's give this a type. Can rename that later. Oops. Okay, so if we're already there, then we just return we should have a set of these paths. So we should have a list of paths. We just want to avoid going backwards, right? And we're not doing this match here exactly. We're going to do visiting a flat map. And at this point, we do case. Each of these has a position and a path so far. And to make the new ones, we're going to take pos.adjacent. Or we have area.adjacent. Oh, no, we don't have that, I guess. We didn't need to make sure it's in bounds. Pos.adjacent, not filter. And I guess we check that numeric keypad contains that. So filter numeric keypad.keyset contains. Okay, so this is our new position. And we just add that onto the path. So we go from new pos to new pos. We want the direction that we went. So we're not going to use a JSON. We're going to take all the possible directions. So dir.values. And then we'll filter here. To get a new pos based on that direction. So we're going to do pos.move dir. Okay, so just a step back here. All this is doing is calculating any new full paths, right? As opposed to just calculating their location, we're just saving the path on top of it. And this wouldn't be the most efficient in a large thing, but since these keypads are small, we don't care about performance. And we can cache this stuff. We do end up caring about performance. Okay, so we have new pos onto a direction. And we want to filter those. Filter. So position and direction, such that we only really want to filter on the positions. and make sure mirror keypad.gset contains it. Okay. So now I think we have what we want, a position and a direction. Well, no, we want a position and a path. So I guess we do another map here. This code that's on screen here can be simplified quite a bit. But I'm thinking slowly, so I'm coding wrong. Direction goes onto the path. And of course, we will have to reverse this when we are done. Okay, so for each of the points we are visiting, we do need another filter. So for each of the points we're visiting, we're getting new paths. This part here should just be, super standard. I should be writing it faster. But we're also going to filter that we're not backtracking. So we'll do like prev.map just to get the position. And make sure that doesn't contain a point. So filter not previous contains our position. You could write this differently. Let's say exists one such that its position is our current position. Okay. Yeah, this thing that's normally a one-liner is a little bit clunkier because we're saving the paths as well. Okay. So we do that. We'll get all these iterations. And at some point, I suppose we could just do the Manhattan distance. Yeah, Manhattan distance from one point to another. So we'll take those and we'll filter all the ones that end there. Array required an iterable once. Of list of directions. List of hold up here. This is what I was expecting to find. But why are we requiring that? Okay, so we take our directions and we take them into pairs and then we just filter on them. Right here without the filters, that should already be we're just adding onto the path. Take some air. That's fair. That's fair. You're doing some yoga first before tackling this. Honestly, that's smart. I respect that. Thank you. Well, at least it is a weekend. Oh, that's what happened. Like the weekend hit, and Eric's like, let's make him not sleep. Uh, Problem is, I've already spent time not sleeping. Um, okay, so let's take this, make a list. We're expecting here a list of a list of point and direction, right? And actually filter not should be the same. Here, we're expecting a list of point and a tuple to a list of direction. Oh, sleep only puzzle. I want sleep though. Check my list twice. Why sleep when puzzle? This will be full of memes. Okay, where's my? Why am I struggling with a type error? I'm struggling with a type error because my code is messy and I can't see what I'm doing. Um, Visiting, we're gonna flat map it to a list of point and list direction, right? So this is a list of point and list direction, or a list of path rather, right? So where specifically is a type error? Method apply and trait linear seekops. Does not take type parameters. Oh, this one here, you mean? Okay. What is this food? This is the type I'm expecting. Okay, so food is the type I'm expecting. Then what's the issue here? Wait. Hold up. Turning that into is this like a problem with indentation syntax? So what I'm seeing here is that turning this into variable and then just returning that variable works. All right, this is some sort of indentation issue then. Hey, I mean, it works now. I don't know. Uh, so we're going to search from a starting set of our from position. So and we're not even using sets. I'm really not worried about performance here. We're just using lists. Num keypad, numeric keypad from. And that is paired with, just an empty list of visiting. And we are gonna, we're gonna iterate on that. So this is, we'll call this our start. Well, this is our start path. So we're gonna have an empty list when we do our iteration, I suppose. This search is really going to be a next method. Yes, semantic white space. We are using Scala. A Scala 3 has significant indentations. But yes, at least we have multi-line anonymous functions. So you can put yourself into even more trouble. You can keep chaining as much as you want. Okay, I'm gonna leave that up there. Um, I'm gonna get a snack, and I'm gonna come back, and I might delete and clean up that code. I think my mind is not thinking clearly right now, so I need food. All right, break is over. Um, what do we have here? What was I wanting to do? Let's take a step back. Um, so you want a minimum numeric arrow sequence. So basically, my thought was to flood fill from to 2, and then take the last iteration of that. So I have yeah, the last iteration being depending on the Manhattan distance. So what I want is like a series of potential paths, right? Um, so visiting is a list of paths. We want to flat map that itself to a list of paths. I think this is basically just our next method here. We basically want to iterate from visiting to whatever the next is. Okay. I'm gonna rewrite this in terms of a next, and we're gonna iterate. We'll state our goal here. Our goal. We start with a list empty of paths, and then a list with just our starting path. So this represents the previous and the current that we're visiting. Um, yeah, let's put start in here. Okay. So case, this is our previous and this is our current that we're visiting. And then we're gonna take next. We're gonna compute that. What is this? Also a list of path. Could be a set path. Normally when I'm writing this, it's a set of point. And then we're just gonna go. I don't think we want iterate. What we actually want here. What we want here is actually similar to not this, because we don't want actually the whole flood. We want all of the stages. I can do this. Let's have some fun. Let's play with a lazy list. So let's call this. We're not going to iterate. We're going to do steps. Now, and at each step there are a bunch of paths, right? Yeah. So at step 0, we have an empty list. So we're just going to do nil. And then at step 2, we have just the start list of start. And at step 3, we're gonna recurse. So we're gonna have steps. We're gonna zip steps. Hold up. Yes, need more coffee indeed. Okay. I was just looking up some old code. Okay. So we're gonna do something similar to this, right? So at this point, we're gonna zip steps with its own tail. So steps dot zip steps dot tail. So now in this case, steps. Well, the first bit we zip is gonna represent the previous, and then the tail is gonna represent the current, right? And then we just take next. we'll use our next function on one of these. We go to current becomes the new previous, and then we take next current. So pretty straightforward. And once we have all those steps, we just take the Manhattan distance step. So steps, and then from.dist 2. And that should give us our listed direction. No, at that point, we still need to filter. So this gives us a list of paths. So we're going to filter. It's a weird indentation. And each of these paths has a point, right? In fact, I think we can do collect and combine our map and filter. So we have a case position that we ended up at and a path. And if the position equals the position of the to character, so numeric keypad 2. Wait, does numeric keypad go from? I need like a reverse numeric keypad. Val, so we want a character position for numeric character position. So it's the map from the character, the point. Oh, Lieutenant Hummus, you write Scala. Nice to see. Well, thank you for saying hi. You're not in the Scala Discord, are you? There's a lot of admin code happening right now there. Oh, Zorankovich solved the puzzle. Awesome. It seemed like the leaderboard was going slow. Did you point today? Yeah, yeah. You should do that and find me when you get there. Okay. If the numeric character position. Oh wait, hold on. This is the position. Hold on. I should be mapping this the other way. So if the numeric keypad, if the key here equals the character that we're looking for. Okay, so numeric keypad of our position equals 2. Then we're going to take the path and, well, I guess we have to reverse it, right? That reverse. And we're going to map. All right. Well, thanks for stopping by. Nice to meet you. Rank 15. Awesome. Awesome. Great job. Wow. Didn't get points for part 1, but you did for part 2. It generalized well. Excellent. Okay. um, I was hoping I'd get like a full complete. So And if it's north, then we have this character. Let's see. I mean, honestly, I should just stick with the directions. So we can have a list of directions. We're not gonna switch to string yet. Um, no, we have a list of directions. So if that's the case, we're just gonna take the path and we're gonna reverse it. Okay, so we take all the paths at that step. Excellent. So now we just need to let's start fresh with the next function here. So def next given previous and current. So these are both paths. And we're going to take our current and match. I guess this will also give a tuple of paths. No, let's give a path itself. Let's make sure everything else just compiles first. Okay, from is a character. I see. So we want we do want to be able to translate the characters to positions. From character. Okay, so numeric carp position. Let's get these names. So let's say val from pause equals the from car. Well, and maybe we should rename these slightly. No, we'll keep it that way. Two pause, and we had the same deal here. Okay. So we have our from pause to nil steps, and we take our from pause at distance to pause. And that's Manhattan distance. We're just taking that iteration of this list of steps. So this is like the growing diamond when you walk from that area. Okay, so we're going to take our, well, let's make sure this compiles before we write anything more. This needs to be a 2 map here. Next given previous and current. Oh, right, this is a flat map here. Wait, should it be a flat map? I think given a single step, and maybe we'll just put everything up in line here. So given any single step we're visiting, so cur not flat map. We have a case here, so we have a position and we have a path. And then we're going to take our, this is where the part where we take our directions. So dir.values.toList. And we're going to filter those for things that aren't going backwards. So or we can just directly create the new path and then we'd filter on the direction, on the position. Right. And then previous can just be like a set of points. Okay, so we take our we get a new position using our direction. So pause that, move that direction, and we got to tuple that with our direction added to our path so far. And then after all of that, we're going to filter to make sure that position, that new position, is not contained in the previous. So we have a new position. We don't care about the path. And we check the previous dot map or previous. Let's do a filter not. Make sure previous dot. We don't want there to exist that point in the previous. Okay. So we don't need to define this next function. I think we're finally there. Exists. There we go. Hey, am I going to stop streaming after AOC again? That's not the goal this year. That's not the goal this year. I will give myself a break. After AOC, what I want to do is make a few videos. But while I'm doing that, I think I'd like to get on just like a weekly cadence of working on a project. And I have a few in mind. But after AOC, I'm going to digest actually, because I do want to improve next year. And one of the ways I want to improve is just by reviewing things that take me too much time, or reviewing mistakes, and maybe reviewing like bits of knowledge that I'm missing. And I'm going to write about that. So I'm going to write about what I learned and make a video out of that. But I do have some side projects I want to work on that I'd be excited to. So you're gonna have a go at the problem. Please do, please do. Right, this should be a list of paths. I'm particularly struggling with indentation tonight, it seems. Oh, right. We do want things to be tupled. So we want the current onto the next. And two lists of paths and required iterable ones of nothing. Interesting. So for each current, we should have we should get a couple new things. So we are flat mapping, right? So this is a path. We should get a new path. Oh, right. This is next here. Okay. I think I found a place where I'm not liking messing with the indentation syntax. I shouldn't be writing this way, but here we are. Current onto next. Okay. Um, and I guess I don't have a filter that these points exist. So let's do a filter. Again, new position should be in the key set. This next should be a path, right? Or a list of paths. The previous and current should also be list of paths, right? Oh, wait, that's the issue here. So steps isn't a list of paths yet. This is the tuple. So after taking all these steps, we're gonna just take the left-hand side. We should assign it a variable name, in all honesty. Or we could do this type here. Okay. So steps.map, we'll just take the left-hand side. So this map should be to the same type. Hmm. How are people finding this problem, by the way? Do we have part one solutions come in yet? Oh, I see what we're doing here. We do want, we did intend to get a list of paths. So we do this zip. After we do this zip, we want to be taking just one end of the tuple. I completely forgot what I was doing. Yeah, you shouldn't be cheating stuff like this. Sometimes I do this when I'm just kind of moving through the motions. Okay. It doesn't matter what this maps to because after we do that map, let's put this on a new line here. So after we do that map, we're gonna get just one side of the tuple. Actually, we only need to return to next, so we can just go straight to next here. Which means, jeez, that's what happens when you don't have a plan. Okay. Hola, hola. Am I going out tonight? No. So this is I didn't go out tonight. Tonight I tried to just catch up on things a bit. But I figured I wish I could go out tonight, so I'm dressing how I feel. Why go out when you can puzzle? I mean, you can go out and puzzle. You know, one of my fastest early on, um, yeah, one of my fastest days early on. What was this? The first year I did this. The first time I got sub 1,000 actually. This night I was out with friends, and then the puzzle came out, and I was like, well, let me step aside and do this. I'll try to be really quick. And then I got my fastest time so far that year. So I was happy about that. I think if you go out and puzzle, that could actually be motivation to get it done faster. Ah. Okay, this whole kind of thing, I do want to like generalize this into helpers eventually because we're gonna have to do the same thing over and over, right? And this is a little bit silly. I'm spending so long on what's essentially just a flood fill. Okay, so we zip these two, and then and right. We zip those two, and we use those two to calculate what the next should be. We take the previous and we take the current. And that allows us to calculate the next by doing a flat map on all these positions. And this itself should return a list of paths. So I mean, this should map to a list of paths. Let's see how the type errors change. Lazy list of path and list of some nil type. Oh, I see. Let's say list.empty path. Okay, list of path or okay, we're still getting that somewhere. So this whole thing is not resulting in a listed path, I don't believe. Let's go back to make. So I'm just going to move this into a next function. So given a previous listed path, my current list of path. We get the next list of path. And it's just this code here. Hold up. Okay, so we have a given position and path. Then we iterate over all the directions. Let's see. Well, do paths. I hate them calling my inner thing and my outer thing path. Just call it a state. Okay. So new states, and then we're gonna filter on those. So let's get our new states. Right. That's good. And then new states, not filter. Check that position. Yeah, so that should work. So now down here, we just use this next function using the previous and current. In fact, we can just map dot map next. Hey, look at that. 99 Parabellum. Thank you for the follow. Map is not a member of. Oh, yeah, we already mapped. So we just mapped to our next function. Okay, and then this here. So what happens when we zip these? So if we zip steps and steps tail, okay, let's do this with a case. Previous, current, and then next, calculate from previous and current. I don't know what's going on with this. I mean, let's say we were to do this with just steps. Lazy list of. Do we still have an issue here? Oh, the issue's happening. Oh. Okay, so we have a list of states. This is a list of states, right? This is a list of states. My type error is somewhere up here. List of point and nil type. Because our start, where's our start defined? Ah, I see. Okay, this nil should be this dot list dot empty of position. Ouch, ouch. This is interesting. I kind of expected it would expand the type of nil, but I suppose it didn't. Okay, so steps dot zip steps dot tail dot map next. Hold up. We're still having that issue. What is start? This should be a list of state. Oh, wait, we have a list of state. I see what we did. So start was intended to be a start state. That's what happened. Okay, I'm happy that that type error was catching that then, because that would have been a bad mistake. List of direction, of course. And I think this actually could still be nil. That will expand properly. Great. Um, oh, so now we can do zip steps.tail.map. Next. Okay, okay. We messed around with lazy lists and that's what we get. Um, cool. And we do this filter and then we reverse the path. Okay. So let's just go look from A to 2. You finally got part 1. Oh, what a night. Meanwhile, I can't um I'm not even succeeding on pathfinding. Oh, nice delta. That sounds spoilery. I'm gonna pretend I didn't see that. But I mean, I saw it. Rotation I can handle easily, I think. I have rotation methods. Um, okay. So we have a start. I guess let's test out this next state bit. The state includes our list of directions. I think I want to pull all my code out of function. So you have a 2 pause. Yeah, let's pull this out. I'm not gonna run a debugger. We're just gonna mess with this. Um, okay. Gonna test our individual bits. From pause equals well, we'll define it from a 2. Up from is gonna be A, and val 2 is gonna be, well, 2. Okay, let's see what this looks like. Let's do next from the first one. So nil and a list of start. So this should give us 2 states, right? There we go. Cool. And then we can take that and we get a flat map with a new next. Um, wait, for each of those we get The next, we also need the previous. I guess we do list dot next with list start, and then that new one. Okay, let's write it in this way. Okay, I mean this seems to work, right? So after one step, we have 0.13 and 22. So we started at what point? What's the point we started at? 2, 3. 1, 3, and 2, 2. Now you need a beer. Great, you've earned it. What time is it for you again? Mm. And this should be a list of 4 things. No? Why not? So 1, 2. Oh yeah, okay, there are only 2. 3. The 4th one is missing because this is a gap. So size has 3. So I'm happy with my next function. So let's look at steps. Steps 0 should just be our, I guess it's our empty list. Do we want an empty list? Would you want to start that way? Yeah, I guess that's our previous was nothing. So steps 1 should just be our start state, right? 2 should be these 2 where we went north and we went west. Okay. And steps 3. Okay, so we actually do want to drop, this first one, but we do want this. So this is, this I want to index this as 0 because we've actually taken 0 steps. And this is those 3 points. Okay, so I mean, that looks good. Let's just, we'll take the tail of this whole thing. And now I guess this filter is bad. So numeric keypad, what is this? This is a map from, yeah, numeric keypad at each point, the character that's there. So what's a character here? Is that our 2 character? Let's make this explicit. So let's take this dot collect. Well, we'll copy that same function. R2 is either trivial or oh no. Okay. So I should abstract my my state transition. Hey, this list is valid. Oh, I think I think the reason we're getting an empty list is because we had stepped too far. So this should be working now. I don't like that it's written in such a way that it's not easy to test. I mean, at least we know that works. Min numeric arrow sequence. Each set's name, so from A to 2. We're getting an error. The easy list evaluation depends on its own result. That's kind of the idea. Oh, right, we can't do a dot tail here. Let's just do a +1. Okay, hey, look, we found an off by 1. Okay, I mean, so we're able to do that. I want to generalize this to work with any kind of keypad. I mean, I can just copy paste this for the arrow keypad. So min directional. And I do think I want to turn that into, before we go on, let's turn this into strings so that we can verify, right? So here's our test. Let's put it up right next to the code we're testing. Def show, and then we have like sequence, arrow sequence. It's a list of directions. You want to turn that to string. So we're gonna take this and app. I'm wanting an exhaustive match, but it's not giving me that. So if you have a north, you have the up arrow. Oh, I'm gonna turn on Copilot here. I want to type all these out. Okay. And then after that map, we're gonna make a string. And of course, we need to do this for an entire code. Key code. Yeah, we'll call it key code and num code. So def key code. Arrow sequence. We need a short name for arrow sequence. Yeah, just call it that for now. So we have a string. And we have we want a final string. So yeah, we take the little sliding list, map show, make string, exactly that. Cool. Isn't any. This isn't a list. What is the type here going to be? Wait, why is that a flat map? because we can just make string. And we don't need to map show. So we're going to show that mid-numeric arrow sequence. We'll wait for each of those. Right. So maybe we don't go to string just yet. This will be arrow sequences. So list of list direction. Okay. Let's zip its tail instead of using sliding. Code.zip, code.tail. So we have a from to. After we take this list, we're gonna flat map it. Yeah. No, not quite. So for each tuple, we're just gonna map. And then we take like all combinations of these to get all our final combinations. Wow. So for each of these, we get a bunch of sequences. I'm going to rename this to plural. Okay, and then we basically just choose a path through there, right? And all of them will be the same length. So if there are like 3 combinations from 1 to 2, etc. And what's the end goal? It's to count. Well, I guess we do need to enumerate. We do need to enumerate every possible thing. Okay, now I think I want to go all the way down with this. Given, you know, let's say we're going 0 to 5. I think I want to know how that goes all the way down to the 4th robot. Rather than concatenating them all right away. And then we can just multiply. Right? Because what we care is find the shortest sequence of button presses necessary for yourself. The complexity is equal to multiplying the length of the shortest sequence. Yeah, the end goal is to get the length of the shortest sequence and the numeric part of the code. Okay. I might pop out the whiteboard in a sec to show what I'm thinking in terms of the math here. So I don't think I actually want to implement this function. And I think for the key codes, or for the num codes, I just want to map it. Yeah, so let's pull out the whiteboard and explain my thoughts for a sec. I think it's worth taking my time, especially if part 2 might be a small delta. We'll comment that out. Okay, so suppose we have our keypad. Hold on, I don't have my pen tray. Where's my pen tray? I don't know why the whiteboard needs a network connection. That is silly. I need the different whiteboard app. If anyone has a suggestion for a whiteboard app, I'll gladly take that. Okay, so we're thinking about key code sequences. I'm just going to go over the math of everything. So we have our little keypad, right? And let's say to get from here to here, we have 3 different sequences, right? So we have up, oh, no, actually 2 different sequences. So there's upright and there's right up. But let's actually do a full code. So let's say we do 0 and then this one here. Right, now to go from here to here, there are 3 different sequences. So there's like up, up, right. Let's draw our path. So we're gonna go from here to here to here. I think that's probably enough of an example. You like Excel draw? Ooh, thank you for the tip. Yeah, I'll give that a look. And then we have, let's see, for the second step, we have up, right, up, and then we also have right, up, up. Okay, so now we have 2 times 6 different different ways just to do, I don't know. Is this 2 and 9? Okay. So to go from A to 2 and to go from 2 to 9, we have 6 different ways that are all minimum. But now we have to think about that recursively. To do A to 2, there are going to be 2 different bot sequences, right? I feel like I'm just starting to wake up now. Maybe whiteboarding is a good way to wake yourself up. I felt like I was coding aimlessly for a while. So A here is where we start. And must we just want to check the rules. So when we're doing the second bot, okay. So the second bot has the same rules. You push A. To input the sequence. Wait, do we need A's between each of these? So that's not 2 to 9. We go A to 2, back to A. Hold up, let me make sure I understand that. So to get 029A, type on here, move the arm from A to push the button 0. Okay, all right, we have to move the arm and then push A in between all of these. So the actual sequence that our bot would be doing is one of these 2, and then we have an A, and then one of these three. So for the next spot, we start A and we can go to up, and that's either left A. So this is the second layer of this one here. Left A, that's pretty easy. And then down right A. Down right A. Let me erase that arrow. I just want to do it for, let's make it explicit that this is for this sequence here, right? And this sequence here, if we go right first, is going to be down A, and then left up A, left up A. Because we're going right. wait. I mixed up right and left here. Okay, so we can go up, left, or left, up. So up, left, or left, up. Okay. If we're going up, left, we do still start with left A. But then we go down, left A, down, left A. And I think these, I will actually just cache them all in a map. Left A, down, left A. Right. And for the other one, there are two approaches. So left, down, left A to go left first. Let's draw a line here. So left, down, left A, and now we need to go up. So we have right, up A. And the other approach is to go down, left, left. Down, left, left A. And then we still follow that with right, up A. And just to be consistent with our format in the earlier column, we have two combinations here. Oh. We have two combinations on the left side times one combination on the right side. I don't think you want to calculate all the actual combinations. We just want to calculate the number of them and multiply. So if we go like further with the caching approach, in order to do this recursively, so for any sequence of two arrows, well, you always have to return to A. And you always start at A. So there's only going to be so many, right? So basically, left has two different ways, down has two different ways, and these two have just one different way. So we can just look at it based on the numbers, right? So this is going to be up has one way, one, left has two ways, 1 times 2. two different ways to get that, and they're both going to be min sequences. Oh, wait, we do have to make sure that this whole thing is a min sequence. So in this case, they both happen to be the same. Well, wait, are they always going to be the same? Yes, they're always going to be the same because they're always going to be returning to A. Oh, and right, I do have to consider the return value. So this is actually 2 squared because you have to return. So you start at A, go to a number, go back to A. Yeah, and then you just do those in any order. Right. Almost any order. I wish this was a full grid. But I mean, as long as we have the number of orders, right? So how can we just calculate this directly? I think we can. Hmm, okay, if I have it in me, in my brain, to make my brain do some math, I think we can math our way out of this, and we're not going to simulate everything. I mean, hold up. Part 2, though. Heard someone say rotate. I heard someone say rotate, so I have to think about it. I mean, for part 2, it's still going to be essentially the same idea, right? Like, there's so many ways to get somewhere. And then you multiply that, well, like, you square that number of ways to get somewhere. Yeah, you square the number of ways to get somewhere, and then all of those things could. So for part 1, all those things could be in various orders, and it doesn't really matter. And actually, I don't even care that it's various orders because I'm going to enumerate them anyway. Right, like these happen to be different orders of each other, but I'm not going to take advantage of that. Okay, I think we have our idea here. So we do this recursively, and we just keep multiplying. So just to take this another step here, let's say there's so many ways to do this. Each of them has a different cost. Maybe. So we have one that is just left A, down left A. Because we go up and then, oh, wait, we don't go from here. We do have to hit an A. Well, no. We're going up. Oh, we have to hit A's in here too, right? So it's not even left A, down left A, left A, down left A. It's left A, right A, and then down left left. So each of these is going to be squared. And here, since there's only one way to push up, that's going to happen once. And here, similarly, we're going up first, and there's only one way to push up, which is left A. Right, so this left A is actually going to be, I shouldn't say squared. It's not exactly squared, is it? It's going to be left A and then right A. So we double the length there. But like the number of options, rather. And then for part 2, this part 2 is wrong it's basically just the same thing here, right? Because you have to return to A. So left A, right A. And then we have, again, two options, left down, left A. Of course, you have to go back on that. So down, left, left A. And from each of these, we can go to two different ways back, right? And it's just that thing in reverse to get back to A and hit A. So right, up, right, A, and we can choose either of those. So two different methods, but they're going to be the same length. Okay. For this, I think I'll just do the map visually rather than doing whatever monstrosity I did for this pad. Yeah, I don't want to copy paste that. So num key paths. Let's make a value called num key paths. So this is a map from a character to itself. Is that another map of characters? Yeah. Okay, and we're gonna write a manual map. So so starting from A to go somewhere. And we really only care about A to something and something back to A, right? So we could just reverse that. Oh, well, we don't need a full map then. So we just take whatever we're hitting. Okay, so if the key we're pushing is up, then we have a list. Do I just do this in terms of strings? I'll do this in terms of strings, and we can have a conversion function later. So we have just left for that. And then that's not quite true. Okay, to go down, we have two options. So we have left and then down. And then we have down and then left. And for left, we have left, down, left. We have down, left, left. And to go right, we just have down. And we could take the sequence all the way back to A by basically taking the cross product of this list with itself. I think we can do that in a later step. All right. So to calculate the number of ways to hit a key code, um, and they will all be the same, I suppose. Let's get all the paths. So we want a function, key code as given a string. And this will give us all the ways to get that. And we can do that by getting the individual bits. Yeah, there's this whole zip thing, which I started writing earlier before stopping to think. And then I think we just want to recursively use this to calculate for each character all the directions or all the paths. Okay, so for every bit of from and to, we do get, so we have these arrow sequences. We're already able to get that. Then we take the arrow sequence in reverse. About forward. Honestly, I'm tempted to So numkey paths. I guess directional key code paths. I want to name these two differently. So this is a map, and we can construct the map using this function. But I want to list it out just so I don't have the bugs. But anyway, so we have a forward direction, and then we get the backward direction. So well, we have all the forward directions, and then we take combinations. So we take forward dot combinations 2, and then we make one of them backwards, right? Let me make sure combinations does what I think it does. So, I mean, I think it does what I think it does. I believe that. But we need to insert A's into there. So to get the key code path given this arrow sequence, this gives us a bunch of directions, a bunch of paths. I guess a path is a list of directions. So I'm going to start calling it that. Type path equals a list of direction. Okay, this itself is going to be a list of paths. So we have a path. We have two paths. We want to just take whatever that second path and reverse it. And then we want to do an A. No, we don't need to think about the A's just yet. And I don't know what this backward combinations is doing here. We just take F1 onto F2 dot reverse. Concatenate that. And that gets us back to A. And this path is what I was hoping to turn. This example. So given that code, let me just think about what I'm trying to get here. So I know 029. So 029A gets 3 different paths. Yeah, so we need to encode the A's. We can't just use the directions. So we're gonna make those strings and then insert some A's. So this is gonna be a list of strings rather. And we had a show function, def show, an arrow sequence. An arrow sequence, I guess I'm calling a path now. Yeah. So we have show F1 plus A plus show F2 plus, wait, F2 dot reverse, because we have to hit that first key and then we have to hit A plus A. Okay. Yeah, so this is on the keypad. So we'll call that the key code. And let's do def dir code paths. So again, I guess it's not code. This is instructions. Wait, if we're calling a path like this list of strings, let's do key code instructions. So possible instructions for the key code. And then instructions. Hold on, I don't like the instructions is already plural. Let me think of a different word. Well, okay. We're going with instructions. So instructions is going to be a string. See, even Copilot is confused by the plural. And now we're going to take these instructions themselves and zip them with their own tail. Yeah. And then it's going to be very similar. So num key paths from num key paths to, and then we'll reverse. I don't like whatever's going on here. Okay, we'll take our forward, and we'll take two combinations of that. So val, I know, forward dot combinations. Combinations of two. There's an F1 and an F2. We do the same kind of thing. Show the list of directions, right? Show the path. And then add an A. Show F2 dot reverse. Okay. So let's test out our key code instructions on code like O29A. Hold up, we have some compiler errors to fix. So from is, this should be a character. To list of pairs of characters, right? Oh, right, that's a sequence. Because we're just zipping, or that's a tuple rather. Okay, from and to. And for each of those, we're getting a list of strings. So for each list, we take all of the reverse paths. Oh, we take all the combinations of two. We could just map here. Every combination of two itself becomes a string. Okay, and then we fix the same thing here. It's the same issue. Do we have other issues here? List of directions. We went to list a string. Okay. So this num key paths is going to be a string. Good. Yeah, and we can choose a forward. We can choose a backwards. And what's our issue here? This case is unreachable. Oh, these are both strings. These are strings now. So we don't even need to show. Like maybe I should have left that as a list of directions. So we just have a F1 plus A plus F2 dot reverse plus A. Okay, so these are three possibilities for O29A, right? And do those look familiar? Right up A. Wait to hit 0. Did they use O29A as an example? Move left, etc. Right, it should always start with the left A for O. Okay, well, let's look up key code instructions for just O. I think I drew my keypad wrong. Because here we should go 0 and then A. Okay, so let's test out this numeric sequences from A. Oh, right, I don't have a leading 0. From A to 0. This should give us one thing, which is just to go west. Okay. Yeah. So we add A to the start of the code. And then we zip that with the code itself. If we did that with this, we'd be fine. So we go from, oops, we go from A plus the code, zip with the code, yada yada. Code is a string, right? Just want to prepend. Let's do it this way. We're still missing the 0. We're still missing the 0. Oh, wait, for part 1, we don't have to go back to A. Let me make sure I understand this. Left A, and then up A. Yeah, we don't have to reverse and go back to A, do we? Right, that only matters for the keypads. So I guess we just take any of these forward bits, and then we add an A on the end. Right, so forward map. Add an A on the end. And we should be happy. Oh, we want to show that first. Okay, great. This is looking better. So 029A. Now we go. Let's see. Let's go from 0 to 2. And there's only one way. So these all start with left A, up A. No, not necessarily. Left A, up A. Yeah, they do start with left A, up A. And then getting to 9 is the trickier one. So let's go from 2 to 9. Right, there are 3 ways to get there. Okay, so this is what we should be doing in steps. So A02 is our froms, 029 is our twos. And for each of those, we'll have several options. We choose one from each. And okay, this part where we're just making a string, this should be cached. I want to cache this as num keypads, code keypads. I wonder why I call this num key, because this is not a num key. This is direction key paths. Let's rename this. Dir key paths. I hate that I'm using both the list of directions and the string in here to represent a path. But at least the type checker is keeping me straight. Okay, so we have options. We choose one from each. How do we choose one from a couple of different things? So let's say we have these two lists. We take I guess we can do combinations of one, can't we? No, but for each of these, we're going to flat map them against the next. So we're just going to do this to get the strings. We'll call this the num steps. Or I don't know, the number steps, the steps for each input. What do we call that? Input options. So for each pair of those, or we're just gonna like fold this whole thing left. So we have like all options. So list.empty of string. All the options not so far. So there's like there's a path so far. What's this gonna look like? Yes, we have our accumulator and we have our list of options. This is a list of strings. No, each of these should have several strings, possibly. Yeah, we don't want to flat map this. This is a normal map. Okay. So we have our accumulator. And for each option, basically, we take our accumulation and then we just add that option. Right? As accumulator, our string. Let's start with an empty string here. Okay. And no, we can start with a list of empty string rather. So a list of options of ways to get to where we are right now. Right? And then these are our branches. So I guess we're going to take our ACK and go flat map. And for each of those, we're going to take all of the options. Pre. So we have like a prefix. I'm going to do pre plus that option. Great. Okay, so now we're getting here. Now we're getting the list of strings we want. All right, that looks good. And now we just do this. We just do this recursively. So to keep going with this example here, let's just try instructions on left A. Yeah, how many ways are there to do left A? Well, looking at our direction pad, we have a numpad, we have a direction pad. To go left, there are two different ways. And then we have to go back. So in order to hit left in A, we need to go left now. Yeah, we should have two options. Four options rather, because there are two ways to get back. So we end up getting left, left A, left, left, down A, which is weird. Left, left, down A. Oh, there's the reverse. Left, left, down A. Hold up. Okay, so let's take a closer look at this. We do have to start at A. Or rather, when we zip, we prepend to A. So we're gonna prepend to A. And then zip that with the instructions themselves. Because we should be starting from the A. Okay, and then our map didn't contain an A. So dir key paths from to our from character. I mean, that should be an empty list. So first step is to go left. These all do kind of go from A already. I don't think we zip here in the same way. Let's comment this out. Let's take our instructions and let's map. I could call this directions. Okay, so we have a it's gonna be a direction key of some sort, right? And we can get a path to that. And then we have to take all the paths in the reverse. So this is a dir key. And then the forward direction is that. Well, these are the forward options, right? There might be multiple. And then we take all the reverse instructions, val. Well, maybe we don't do that just yet. So we take forward, we take some combination of two of these because we'll use a forward to generate our backwards direction. So forward, that combination's two. And then map. So we have an F1 and an F2. And you do the same kind of thing. So we take that forward, we add an A, reverse the reverse option, and add in another A. Okay, and then that's all of our options for each of these directions. And we have basically the same code as in the key code instructions thing. So val input options equals that, and we can just fold left across it. I'm going to remove this paren here by turning into colon. You really need to know the name of my VS Code scheme. You like it, huh? I chose this one specifically for Avena Code because it sort of matches the website. This is Outrun Night meets Synthwave. There's also Outrun Electric. Both of them are kind of close to the AOC color scheme. I'm gonna do this one for now because it's a little bit lighter. I sometimes switch between these two. But right, you got the greens and the yellows and the purples, and it matches. Okay, so we've got that. And like I feel like I could generalize this, but okay, left. Oh, and at the end there's an A. And the A we can ignore. If we're told to do an A, wait, what does it really mean if we have to hit left then A? I guess you go back. So you input the directions to go to the number, right? So like, you're going to 5. So left, up, A, down, down, right, A. So that's this bit here, forward and reverse A. And since you're already on A, you just add in another A. So you should always already be at A. So draw key paths dot get or else. Oh, hold on, we have to be careful here. Because when we hit that A, we don't need to like reverse anything, right? So this whole thing we only do if it's not A. So if it's an actual direction. So let's make this a case match. Case A. Then for that, it's really just a list of we ourselves hit A to make it hit A. This is kind of brain bending. Otherwise, we have some direction key. And then we go the forward path to that, the backwards path to that. And we hit A to enter that. Wait, do I go up to the 5? No, I think I'm missing something. So up here, let's say we're told to go left A, up A, right up A. So yeah, we're gonna go. So our bot that's following instructions hit that is gonna go down left A, right up right A. And the right up A is in order to hit this A. So we're already hitting those A's. Right, because we're going back. So we should be ignoring those A's rather. So A is just this reverse. Oh, you know what? Let's keep it explicit. We're just gonna do like reverse directions as well. I don't think we need to be doing. Yeah, so if it is A, it is the reverse. So we are jumping ahead of ourselves by doing this f2.reverse and then A, because then the next instruction is going to be A, which means do A reverse and then hit A. Yeah. So we could ignore this. And I think that would work as well. When we are told to hit A, we just do nothing. I would fix it, or an empty list. Is an empty list right? Or a list of empty string. Jesus. Okay, so to hit left A, we go, well, there's still only one option. What's going on there? Today's problem got some hands. You're surprised someone hasn't done an AOC matching color scheme for VS Code by now. I am too. I thought I looked when I was looking for this. Someone should ask on Reddit, and I'm sure someone will be happy to do that. One per keypad. I'm not sure I remember what you're referring to. Method map and class iterable extension methods is, options. It's a string. It shouldn't be a string. Options should be a list of strings or a list of string. Yeah, for each character, we have different options to get to that character. And right, whenever we get an A, how to get to A depends on where we're coming from. Hence that zip I was doing earlier. And I should just expand this to include the A's, or I can reverse if the first one is A. Then I don't have to do both this forward and this reverse. Hmm. Right. So for these instructions, we have a bunch of strings. No, we don't want that. So we're going to have our instructions again with the A prefixed. We're going to zip that with the instructions. And this toList.map thing. Cool. So we have a from. So if we're coming from an A, we're going to have a different direction. Right. Yeah, we're going to do the reverse thing. Otherwise, case, we just have a regular from and to. And when we have a regular from and to, well, our forward direction. Oh, wait. Are we potentially going from an arrow to an arrow? I think I had made a bold assumption somewhere that we always go from an arrow back to A. So when we do this test here, This one's tough. I'm off by length 4.379A. I just wish I had a brain right now. I think the tough part of this is just keeping it tracked in your head. I don't think it's like it shouldn't be conceptually tough. Like I don't think the math part is tough or the enumeration. Too low has a common reason. How do you know common reasons already? Like I thought you only had a handful of beta testers. Or are you already checking Reddit? Um, okay, let's look at this again. So to do 029A, we need to do this sequence of moves, which is left. We need to get a robot to go left A, up A, direction, direction, direction A. And now to get a robot to give those instructions, we're starting at A. So we go left, multiple ways to get there. And then we do have to go back to A. The new robot is going to go back to A. Yeah. So we go to the arrow, we go back to the A, we hit it. So it is the same thing as in here. So we don't have to consider the A case. Especially. Okay, so for the first character we're hitting, we have our from to. We have a path there. Let me catch it. Oh, you're reading from the subreddit? We've had a ton of help posts and 90% of them are the same problem. Interesting. People are writing help posts already. Just go to sleep. Wake up in the morning. I've often found, well, I found that in the cases where I do go to sleep and wake up and do it in the morning, it's just so much easier. Yeah. You had help posts within minutes. Did you have help posts before the leaderboard filled up? Because there's like 15 minutes or only a few on there, right? Oh, I'm not gonna read that. Oh, wait. I mean, of course. I already get what that's about. I think that's obvious. Um, yeah. So that doesn't feel too spoilery. Wait, this is a literal A. But, nah. Okay. So we have a from and a to. The thing is, this Durkee paths is always just gonna count from the A. So if it's from A to 2, then our forward direction is it necessary to do this implicit starting at A? And do I really want to zip? Because for each key that we're pressing, let me think about that again. For each key that we're pressing, left K up. So we might hit, let's say we're hitting the key that's right. So the instructions we're going to give are to go to the right key, go back, and then hit A. And then from there, we're going to up. but we're already on A. So we'll always be on A. So we can actually do this one at a time, right? So we're starting on A. So we just do like directions to get to the left key, A, directions back, A. So forward, reverse, A. And when we see an A, we just give the direction to hit A. So we don't need to be doing this this zip thing. I've been waffling back and forth, haven't I? We do want to have a variable called list options. We're going to just take our usual instructions here, and we're going to map. And if it is an A, then our options are just to be just to hit A. We don't need to worry about forward and backward direction. Right, here we go, left hit A, right hit A. And when we see an A, we hit A to make the thing hit A. Left so many times to hit, and then we hit A to hit the left. Right so many times to hit the A. This is why I keep waffling. I keep mixing up my analogies. Do you see what I'm do you see the circle I'm running in here? Um yeah, I imagine it's hard to follow because making it more confusing than it is. Yeah, this is why I get it, but this is also why I want to go deep first. Right? So basically my end goal um is for each letter here, I'm gonna calculate like its options. That way, like its options all the way down. How to get you know, let's say you start with 0. How do you get 0 from the fourth robot down the line? And then how do you go from 0 to 2 from the fourth robot down the line? Um, that way, for each of those steps, I already know what the fourth robot's doing. That way, I can actually minimize it properly, as opposed to like a breadth first kind of thing. So I appreciate the spoiler consciousness. I might add like a spoiler filter command for people that want to type spoilers to each other. But I don't think that happens to be a spoiler for me. Um, okay. So one last time here. What are we expecting? So for this first one, we want let's just do a manual version. So directions to the left key. Right, let's pick one. So left down left. And we have to hit it. And then we'll have to hit A next, but we shouldn't use that knowledge. We should just well, we don't have to hit A, we have to make it hit A next. But that's already given to us as an instruction, right? So we should calculate going from this left to A. And then when we hit A, that makes it hit A. That's the point at which it hits A. So like, yeah, we should treat this exactly like the key code instructions. So I'm back and forth once again, but now I'm more confident because I'm now conscious of the circle that's going in. What's up with my music? Okay, so we prepend this so that we know where we're coming from originally. Uh, okay, we prepend the A onto the instructions, and if we're going from an A to something, then we just use our normal dir paths. Dir paths to 2 dot map A. So that's the directions to get yeah, for each of these paths, we're going to add an A onto the end because we have to hit that 2 that we're going to. And if we're going from a number to another number, well, those bits are missing. But if we're going from 2 to A, if we're going from 2 to A, we can just do, or like from to A, just reverse these dir paths. So dir paths to what? From. So that reverse, and then we add an A on the end. Okay. But I mean, now this is where we realize this should in fact be a nested thing. Well, okay, this worked for part 1, or this worked for the key code instructions. Did we even use it actually? We didn't use it. So this is implicitly like coming from A, right? There's that map. And then we have each direction. Do I really want to do this manually? I can copy paste this code and just pass in a different, just do a different map, right? But I feel like it's small enough. Okay, fine. Fine. So we have to do dirpad. So we have the raw thing again. It's just copying from my last implementation. So there's a space up A. And then there's a left B right. So we have a map from character to point to its location. Okay, and then we had min-numeric arrow sequences. I'm not going to use a big long name like that for this version. What do we call it? So we'll just say def. For each of these, there are ads. We're just going to assume that's minimum. So we'll call it dir paths. So given a start and an end, given a from character to character. And we're going to return a list of strings. All right, Eric. Thanks for sticking around. Always good to have you chatting. This isn't greedy. Mega memoization. Yep, yep. So I wrote this originally here because I was like, well, I can just enumerate them all and it's already memoized. Um, but I'm going to have to just memoize it after the fact. Um, let's see. And that's also the reason that I was happy to have this be like a slow implementation. Like this isn't particularly efficient or nice to read, really. Um, but yeah, like there aren't that many of them to compute, and then you can just pre-compute everything. Well, I'm not even gonna memorize. I'm just gonna pre-compute all the combinations because it's so small. So almost memoization. But we do want to do something like dir key paths, where it's a map from uh, a pair of characters to a string, which is just this. Um, so we calculate the direction paths. And yes, we have the same thing. I don't like this code. There's a nicer way to there's a nicer way to write this. Um, there's a much nicer way to write this. But right, this is basically my code from above, but adapted. Maybe I'll just go with it. And do we use dirpad in here? Yeah, it knows what I want to do. So let's try this. Dirpaths from A to 2. Wait, no, not A to 2. From A to V. Oops. Um, my worksheet's not running for a sec. Standard pointer. What's up? How is your AOC? We should get two different options for this. So I'm testing this out. And then we're going to re-implement this as just a pre-computation of everything. And like, in a worst case scenario, I end up wait. Keep that old version here. Something like that. Okay. Wait, you started day 1 today? Yeah, you can rarely go wrong starting from the beginning. It's true. It's true. Okay, so this is going to be like our memoized version. And we'll just pre-compute the whole thing. For what? From in that to in that. We're going to yield that, and that whole thing is going to be a map. So map.from. Okay, there, all cached. I don't know why My worksheet seems to be dead. I do kind of want to re-implement this yet again. There's got to be a nicer way to do it, right? And yeah, there is a nicer way to do this. So I'm gonna the start of the stream I was kind of super hazy. So I will re-implement this, and then if I'm finding bugs, I don't think there are bugs in this one, but I'll just re-implement this in terms of my new implementation. So I think that will be fun to do. I just need to run and grab some water real quick. Be right back. Okay. Um, so what am I doing? I'm writing this search for paths, right? Because I want to just cache everything. Um, so let's represent a path as a string representing its history. So type path. I have path defined elsewhere, but I'm going to redefine it. Or, you know what, we're going to do a case class actually, because I want to go get the next. No, this is some state. So this is some search state. So state has a position and it has a history, path so far. And we're going to define a next function on here that just gets us all the next states. And for each of those, actually we can just make this so this will be a list. So after the fact, we'll just do filters on the positions of the state. So potential continuations would be list of let's say position Um, no, we have new states. So we can just do posit north onto, let's see, we just add to our path the north symbol, right? We're not going to worry about directions for now because we're not actually doing anything that needs to really be aware of directions. So posit south, etc. Posit west, posit east. Okay. They're super readable. And what I had done previously was like a flood fill up to a Manhattan distance. Um, I guess we can just search to the Manhattan distance and then filter everything that's on the correct position. So we start with our starting state. I'm going to turn off Copilot because it keeps wanting to rewrite my old code. So I'll start equals state from, geez, the location of from. Yeah. And in this case, we do, where's our dir pad? Yeah, direction pad from our from. To get a starting position, and we start with an empty string, right? And we're going to do an iterator dot iterate. So we start with that list. And then we just do, we take all of those states we have so far, and then we flat map each of those to get their own next. And then when the string is long enough, then we are done. So zero, the 0th step here is going to be, let's make this a lazy list. Val steps. So 0 steps, we're still going to be at the start with an empty string. So you want steps at the Manhattan distance. So list equals dirpad from dot dist to dirpad 2. So steps at that dist. Oh, this is so much nicer. And then we're going to filter on those. So filter such that the position equals dirpad for our from, for our 2 rather. Well, actually, a dirpad gives us a point. Wait, is that what I did here? A character to a point, a character to its position. Yeah, I think that makes sense. Okay. Character to its position, and now we just map and get the paths. In fact, we can do this with a collect case state pause path if pause, or rather if dirpad 2 equals pause, then we just return that path. Okay. So let's give that a shot. And what's going on here? We return a list. Oh, Come on, Copilot, you know better than that. I mean, I guess it could be a tuple, but you want these to be states. We missed a paren. Okay. So that works there. Now Durkee Paz. Now we don't have to do this nonsense with trying to decide whether it's an A or not. We just have the tuple from and to, and we get that path, those paths with that tuple from to to. So those are our options, and then we just construct all the possible options. So let's try instructions for left A. And there are several ways to do that. Cool. So now to do like the robot instructions. How many robots down are we? So fourth robot. Um, these robots are not designed for button pushing. In particular, if a robot arm is ever aimed at a gap where no button is present, the robot will panic. So don't do that. Oh, hold up. Ah, this won't work if there's a gap. Good thing I read that because that's not covered in my that was covered in my original implementation. It's not covered in this new one. So let's make sure we don't have those gaps. So at each step, we don't just flat map next, but we make sure we need to filter that we're inbounds here. So next is a list of paths. And I guess we could make sure that we're not backtracking, but I don't think that really matters. Again, such a small search state. As long as we're at the correct Manhattan distance away, then they'll be in there somewhere. So we have, say, paths here. And after we take the next, we do need to filter such that precision is in the key set. So we have the state, and then we have dirpad. That values that contains S. Okay, yeah, that works. That works. I should perhaps make sure this is distinct. I don't know that it isn't distinct, but again, performance doesn't super matter here. I guess that, why not? Okay. So direction paths from A to V isn't giving us exactly what we want. So let's look at the distance. So dirt pad A. Do some testing here. Let's check out the let's check out the distance. It should be 2, right? Cool. things are working like we expect. It might be this again, an off by 1, but I doubt it more this time. So let's check out next from that A. So state that A position, and we have an empty path, right? So that's iterating all right. And geez, let's calculate this. So list of this start state. So steps 0 should just be nothing, right? Or that one thing. These are all everything that's 1 away. And I guess our filter is too aggressive. Let's just take out this filter temporarily and see what it gives us. Yeah. So it gives us 4, and some of them are in the wrong direction altogether. Well, 2 of those are out of bounds. So this filter is wrong. Our direction pad values contains s.pos. So contains is not type safe, which is a a little bit annoying. So now that looks more like it. Okay. So we're able to do that. We're able to do keep, do our cache. Great. And now this is a smaller list. That seems more accurate. Now I need to know the number of robots we're doing this, and then just do this recursively. So for each possible, so back to the high level here. Well, let's make sure we know what our number of robots is. So there's one robot pushing the keypad. And then because of variation, another robot is pushing a directional keypad, so the dir pad. And then okay, so a second different directional keypad is used to control this robot. And since it's too cold, there's a third directional keypad. Okay. So basically for every kind of key code, or for every like pair of numbers we might push, we do the direction pad 3 times and then the keypad. So we can just nest this. Yeah, that works. Inza Devin, thank you for the follow. Let's do this manually and see what that looks like. So let's say we have this 029A, right? Just to hit 0 is left A. Sure. well, actually, let's do this with the full instructions. See how this works out. We're just going to iterate on instructions. So iterator.iterate starting from the paths we get from this key code instructions. So that gives us a bunch of paths, a list of strings, and then 3 times repeatedly we're going to take that list of strings. So take those paths, and we call instructions on that path. So paths.flat map instructions. Now here I might expect performance issues, but we'll see. So the next is hitting it once. We're using 1 direction pad. We're using 3 direction pads, so we do .next on this iterator. But surely we should do drop 3.next. Okay, and have I cached the key code instructions yet? I mean, this probably works. So these are all valid, but we want how many min paths? So val 3 deep paths. The naming is kind of difficult in this one. So this is a def given some code. And I want to do this. Like, I think ideally I cache this per character, and then I do a kind of build up like I do here in instructions. But apparently this is performant enough for now, so let's do that. For code. And we just start with that code. So I know for each of our codes, let's just try with our 029 example. Here's the shortest sequence, but how many shortest sequence? Like the length of the shortest sequence. Okay, so let's do 3D paths for string 029A and that map, that length, and then that min. So 29. So for 029A, 68. It should be 68. Did we go deep enough? Do we need to drop 4 actually? Am I off by 1? Did you notice the time it took to do that? Okay, that step from 3 to 4 didn't grow anywhere nearly enough, I don't think. So let's examine this. One step at a time, just so we can kind of see where the bug might be. We need instructions for each of these. So rather, we're going to flat map. Is this 0 to 9a accurate? So let's follow the example along. So this part is at least accurate, right? You all start left A, up A. There's not much of a choice. Right, up, A. Right, up, A. Up, right, up, A. Up, right, A. Okay. And then they all end with V, down, 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 A. Okay. Let's check what it looks like in the second step. There are multiple shortest sequences here. In that case, let's get all of those multiple shortest. So the second level, they're multiple shortest. Let's group them. Let's just group by length. And then min by the key, which is length. Oh boy, so 16. So this is a type that, and then this one such sequence. Is this length 16? No, that's length 28. That's not one of the shortest. So we've messed up on our instructions. So let's take a closer look at an example there. To tell the first type 029A, one such sequence is that. Let's tear down something step by step. So let's get these instructions here. So just to get left A, we already have that. Today is best in you. I don't feel like I'm stuck yet. I'm just slow. But yeah, it's a gnarly one. So left A, up A. Let's do it for each line. Okay, so there are 4 ways to type left A, up A. Does that stand to reason? Okay, on the second step here, to type left A, up A, you can go down, left, left, down, left, left, down, left, down, left, down. Okay. That makes sense. What's missing here is the A's. I forgot to add in the A's. Yeah. So it should be down, left, left. Hit A to hit left, then right, up, right, hit A to hit. So we're missing 4 A's. That's a very easy fix. So dir keep has plus the A character at the end of that. Wait, we got map. Map plus A. Okay. Now let's take another look. You spent 15 minutes figuring out I had a capital V somewhere in your code. Oh no. I mean, it's nice that we have a harder problem, but I haven't recovered from the week. I know like yesterday was supposed to be an easy day and the day before, but I've had a work week. Friday night, I kind of want to sleep, but I'll sleep tonight. I thought I was gonna sleep last night. Okay, so let's see what this is printing now. If it's printing anything. The dir keep has cached, honestly, should just already include the A. So I'm gonna do that instead. So dir keep has from to we take all these dir paths dot map plus A at the end. Oh, when did I run things too much? Is it this stuff? Let's just make sure we can debug this first. Yesterday was bad. Oh, no, you're right. Yesterday was bad. Yeah, yesterday wasn't a break. Uh, it didn't feel like it should be bad. So yesterday, once I knew my approach, it took me 15 minutes to write it. I just bumbled around for 2 hours. I started tonight's stream by doing part two. I had half an hour, and I thought I had implementation, and I think I wrote up pretty quickly without bugs, so it was implementation I wanted, but it was not the implementation I needed. Okay, so let's start thinking about performance optimization here. So for each character, there's going to be some number of ways to push that character, right? So what we should really do is we just iterate 3 times for each character. I guess for each character combo, right? And then, yeah, for each character, we iterate 3 times. So to hit the 0, we take the shortest of those, or the set of the shortest of those, right? Or actually, we only need the count, because we don't need the actual things. And then to go from 0 to 2, again, we do the same thing, calculate all the 3 depth, or rather the number of 3 depth ones. Similarly, all the way around. So I think that'll be easy to implement. So let's just make sure this looks good. Yeah, that looks much better. And is the length of doing this for let's see, I wanted to check my min length one. Is this size 28? Yeah, it's size 28. Okay. So I feel much more confident there now. 3D paths. I'm not going to bother with that because I think clearly my thing crashed because it was going too deep. So let's do 3D paths for just a single number. We'll do this step by step, exploratory, just so we know what we're doing, and then we'll wire it up as a proper function. So to hit a 0, we have key code instructions for 0, right? And then we had this kind of 3 deep. Let's do 3 deep for 0. And all we care about is the min lengths and the count of the min lengths. So count min, let's get a list of paths. Yeah, paths list a string here. And this will be an int. And we just do the 3D paths on this. Oh, no, we've already done the 3D paths. We take the paths and then we group map. I'm just going to get the counts. So we group by identity. And then we get a list of paths, right? So for each of those paths, we get the length. And then we just sum up those to get the number of each. Yeah, the number of each length. Where, like the key is the length. So then we're going to map and get we're going to get a min by. So min by key, which is the length. And then 2, which is the number of things at length. Okay, so let's count min paths for 0. Or for count min paths for 3D paths of 0. Nope, just a 0 string. Okay, so there are 60 at the minimum length. And do we even care what the minimum length is? We don't really, do we? Okay. And now we just multiply this across, except now I'm feeling like, how did we get 60? Let's do distinct here, dot distinct. That should already be distinct, I'm pretty sure. Right, there are slight variations. Okay. Well, there are that many ways to type 0. I guess so. I mean, I guess for the other ones, it might narrow things down a bit. But if there are 60 minimum length ways to type 0, and like 5 minimum length ways to type the 2, then that's already 300 ways just to type 0, 2. Right? We want to multiply those. Like, look at this. I want to know the length of this. Yeah, 68. So to type 0, it's simply left down A in order to get first robot to move. Okay, I think we were happy with instructions, right? Like this was getting us things of the right length. For 029A. Which is to say, what, 28? Let's take a look at that again. So it key code instructions for 029A and but we flat map that with instructions. This is way too long. And let's count length equals 28. And did it tell us how many there, like length 28 ways were to do that? So the second step here, like one such sequence is that. So we have 64 different ways to do that. And that's sounding like too many ways. So let's filter those ways and look at each of them. Right, we're getting the right length, but we're getting some weirdness here. So let's start with the 0. Count length. What's the minimum length? So dot min by length. Length. So the minimum length to type 0 is 8. Okay, let's count those. How many are length 8? Eesh, something is running a while. Okay, so let's print all of those. Filter, and for each print line. Okay, so we'll print all 4 of those. Okay, and to type 0, we either down, left hit A, which is to say, well, so we need to hit left and then hit, yeah, to type 0, we need to go just left and then push. And there are 2 different ways to go left. And then there are 2 different ways to go back to A. So it makes sense that there are 4, right? Okay, so I'm feeling pretty confident about that. That looks correct. Let's examine the 2, I suppose. Let's examine the 2. Because we are getting too many for one of these steps, and maybe the 2 is too simple. Oh, wait. Keep going instruction number 2. The 2 isn't starting at A, it's coming from a 0. Yeah. Took you too long to realize how some inputs can be longer. Okay. So our calculation is just wrong here. Well, we do get things of length 28. We're just getting too many of them. So we do instructions. We prepend an A when we do instructions. But in this case, so we have to do 0, 2 when we do instructions to get the right idea. We can trim the first 8. Oh, that's not going to work for us. Okay, so inside of instructions, this bit here needs to be a separate function. Yeah. So let's get. So let's say for a movement, or for a direction. So in this instructions, um, well, I mean, even in the key code instructions, we need to separate this out. So we need to refactor this a little bit so that we can just get the from to part. Oh, and we don't need to build the whole thing. So what this does is build the whole list. I mean, I guess you do need to build the list to pass the instructions on to the next step. I'm just gonna go straight to counting the three, count the three deep from here. I think we can do that. We won't even use these functions. So def count three deep. When we have our key code and we're moving from a character. So these are keys. And we're going to another character. And we essentially just get the minimum at each level. Key code instructions gives us, so key code instructions gives us minimum paths for that particular key code. And instructions will do the same thing. It's just not necessarily the fastest instruction, right? So we're ultimately going to get an int here. Do we need to actually know the path? I don't think we actually need to know the path to get to count the minimum ways to do that. So at the first level, there's essentially this A. Actually, no, we're not prepending the A, we just had the from and a to. So we have this min numeric arrow sequences. This is the thing I was wanting to cache. I think maybe, wait, have I cached it? So there are keypads. I think I want code keypads. Or num keypads, rather. Num keypads, which I have not defined yet. So we'll cache that as well. So val dir keypads. Let's cache val num keypads. So a map given any two characters, which belong on a num keypad. We get a list of string, and these should all be minimum length. And we'll do map dot from. So from can be any of 0 to 9 plus a. 0 to 9. And then plus a. And then same for 2. And again, we yield this from. And set derpaz. It's min numeric arrow sequences. Min numeric arrow sequences. Do we need to add an A on the end here, though? Let me think about that. So this gives me a list of directions to go from one character to another character using the keypad, right? And once I get there, I do need to hit A on the keypad. So hence the A here. Cool. Now let's go back to our count 3 deep. Oh yeah, I basically just took this and cached it. So now I can do num key paths. So num key paths from to 2. And now for each of those paths, I'm just gonna do this manually, like one layer at a time for now. So we've got a path, and now we can do a similar thing to down here. So dirty paths from the 2. Oh, and in my key code instructions, I don't need to be adding an A now because I've cached that. I mean, I guess I'm not actually using my cache there. So this path gives us a bunch of froms and twos. A bunch of new like nested froms and twos. So we assume that we start at A for each of those. We do, but I don't want to be calculate. No, these are all cached. So let's take path with the prepended A. Zip with itself. And for each of these, we're going to have another nested from and 2. Okay, but now in this case, this is a direction. So we do the same thing, but on the direction paths. So dirty paths with from to 2. Great. And for each of those, we also flat map. But let's say this was the innermost nested flat map. Then to get this count, you look at each of these paths. Each of these paths has their own length. So each of these paths here are going to be a minimum length path for that key itself. Oh no. Oh no. It's not necessarily true that a minimum length path for that key going left and going up. I mean, okay, I've said this multiple times. So I'm just nesting this in the wrong way. Okay, so I think essentially for each from to 2, I do still need to find the minimum length path. Could it be the case that going up, 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 left, down is ever better than just left, up, or up, left? I mean, it could be the case at a lower level. No, I really don't think so. Okay, I don't think I have to worry about that. Okay, where were we? I don't want you to be airing out yet. I'm not done writing you. So we take the direction key paths for each of those characters that we're pushing. And suppose we're trying to get the lengths right now. So each of those paths has a length. So now each of these from 2 steps in a num key has a length in terms of the bot below. yeah, each of these paths, and then each step along that path has a length. So if we were to do like dot size here, then we have bow lengths equals that, right, for each step. And then now we want a minimum across each of those steps. So each of those steps has a size. Um, each of those has a size. Let me just take a look at our Durkee paths. Wait, what's this? Oh, yeah. Oh. Maybe. Uh, I still can't shake the feeling that I need to be more buttoned up in the way I'm doing this. So that's why I'm hesitating. Um, Nevertheless, for those, for each character that we're pushing, for each from to two, um, we have a path. Let's draw this so I don't lose myself. Okay. Okay. So we are looking at something like going from A to 2, right? And we want the minimum length. So we're going to have like a couple different paths. So here at numkey paths, we have at the highest level, we have upright A. This will be the instruction for the robot. Or we have, is it upright? It's left. It doesn't matter. So let's say upright, and then we have right up A. Now for each of those paths, we then take each pair, including a phantom A here, because that's where we're going to start. Yeah, on the keypad, we should always end up back at A. So there'll be a phantom A. So this step here has a bunch of paths, right? They're all going to be pretty minimal length. And this step here is going to have a bunch of paths. So that's what we're seeing here. Lengths. So we do the zip. When we do the zip, we're getting these pairs. And for each of these, we get a bunch of paths. Right. And now to count the minimum length path on this one. And this is where I'm feeling like I need to go bottom up because I think it makes sense for the num key, for the key code, but not for the direction keys. Maybe. Because these are all going to be the same length. It's like either 2 or 3. Right, because we use Manhattan distance at each step down the way. So like the whole length of this is going to be um, the size here plus the size here plus the size here. And I think I'd do like the minimum size of each of these. But that doesn't work. The fact that it's all the same is sketching me out. Wait, but each of these direction paths, itself, yeah, each of these direction paths itself should have right. Like let's say to push up or to go from A to up, we have this path, but maybe we have another path. Now each of those paths should have a different length. So we should go down a level. So I think at the first level, I guess it is always going to be equal at the first level. Right, and then we're going to do the same thing, tupling this. And for each character, we're going to have more paths. But depending on the path here, like this is where it differentiates, right? Going here, this is going to be the same number of characters, but each of these is going to have a different length. So this one might be short ones. This one might be longer ones. It's basically like choosing between 1 and 2. So we recursively have these groups of paths. So we do have to get the lengths of each of these. I'm going to continue with my recursion. And again, this is just going to be a manual recursion for now, so I could keep track of things in my head. So again, we get our froms and our tos. And then we recurse. So when we do this map, we're going to want the minimum for each of these kind of recursive paths. And again, we're going to do this. I want to write this less nested. So I'm going to do this in a for comprehension. Yeah. For now, maybe we might avoid doing the count. I'm not sure. I might need to break this down into steps. So numpad paths. So we take all these numkey paths, right? Let's call it paths. We'll call it paths A. And then like 0, 1, 2 for each of the 3 levels, or 1, 2, 3 for each of the 3 bots. Or paths at the 0th level. Okay. And then we'll get a bunch of potential paths from paths 1. From recursing based on path 0, right? So we take this A onto path 0, zip path. Okay, so we still want a list of paths. I don't think it might be accurate to merge all of these paths, though. Um, so we have a bunch from to low level. And for each of those, we're basically doing count 2 deep, right? To figure out its minimum length. So I'm going to take a step back from this for a second. And just for a direction path. So from a direction character, we want we just want to get the minimum length path for that. And then work our way up, right? Um, so dir from, so this is from the dir pad. This is a character. And then dir2 is also a character. We're going to do int. And this part's super easy, right? We can just do dir key paths from to 2. And for each of those, we take the minimum. Or wait, I mean, there are so many paths, we just take the minimum length. Okay, and when we're doing that at 2 levels, um, okay, so we have a Durman path, right? Now we're gonna go 1 deep, def min path 1 deep. So this itself has its own from and to. And it will generate a bunch of paths. And for each of these paths, we calculate how long it'll be. Yeah, so we take that path and we calculate dir min path for each of its own from twos. Right, that's this recursion here. So we prepend a path zip zip path, and now we have a nested from 2, from 2, and for each of those, we're going to get the dir min path. Okay, and then now that we have a min path for each of those, like a length, let's just be drawing this out. So we have a from, and we have a to. We have a bunch of paths. different lengths. And for each of these, we're going to itself have a bunch of paths for its characters, right? So let's say this one has 2 characters. So this one has a bunch of paths, and this one has a bunch of paths. And given those 2 characters, we can get the min path. So we want the min path for each pair of characters, right? So for each pair here, we get we get the min path. And then I suppose we just sum that. Yeah. And we have a syntax error, not an arrow, but an equals. List of int. Right. So for each of these paths, we do want to just map and get its cost at the lower level. So this is its cost at the lower level. And for each of these higher levels, we get, well, the cost at its lower level is minimized, right? For each higher level path, okay, back to the drawing board here so we can think about it properly. Okay, so here are our higher level paths, right? There is we get a bunch of from twos so that we can get the lower level paths. So for each lower level path, we can easily get kind of the minimum. So this will have a list of minimums, which we then sum, right? But then this will have its own, so, we get sum of minimum. But this also has a sum of minimums, and this has a sum of minimums. So we get the minimum of all of those. Okay, we have an issue here. This is a dir from. Okay, so that's what looks like one deep. And geez, I was wanting to nest these all into one function. That's kind of crazy. I should just go straight to abstracting it. I think I want a function that given a path gets its minimum at the lower level. I mean, path too deep is basically going to put this here in the middle and take its sum. And then for each of those sums, it's going to take the minimum. Man, my brain is fried. We're just going to copy paste that and yeah. Not abstract it. I can't abstract right now. Min path one deep. Yeah, it's the same thing. Like that should work. That should compile. And then now we get the min path 3 deep for any given pair of characters. And like this is where I'm starting to feel like I should have done this at a level of paths. Because at this point, now we do need to do this for the code itself. So this is 3 deep for any kind of given character. And now our full code. Def full code min deep min path. Okay, so given the code string. Oh, and at this 3 deep level, we're not using dir key paths anymore, but we're using num key paths. Right, because that's what those characters will be. It doesn't like that because I just haven't finished writing this code. But we do something similar to this inner bit, right? Which is we phantom start from A, zip together from 2, and we get those sums. And then the minimum of all of that. Oh, wait, I mean, the sum of all of that is our answer. So path in this case is a code. Yeesh. Okay, copy pasting, you gotta be careful. Change the variable names. Okay. So now, I mean, I think this we could run with one of our codes. So 029A. And that should work. Plus a member of listed direction. Where is that? In numeric arrow sequences. Listed direction plus. Oh, how long has this bit not been compiling? So we're gonna map. We gotta do a show here. Listed direction. Listed direction. Yeah, show that listed directions. And then add the A on the end. Okay, so we get 164 for 029A, which sounds too long. Yeah. But I mean the idea, let's look at the idea from the top down now. So for each pair of letters, there can be multiple paths once you go down at the 3 deep level, right? So we look at minimum length paths to go from each pair of letters for like 0 to 2. We can test this. I want to test this actually on 0 to 2. So let's do that. Or A to 0. A to 0. Yeah, let's start with A to 0. See if there's anything surprising there. $46 already. Did I go too deep? Because, I mean, when we did this 3D paths for a code, okay, 3D paths. So this just gives us a path. Going for 0. That will start with A to 0, essentially. So that gets all those paths. And what's the length of each of those paths? Right, this just, well, That gets all the paths, but it does some pruning of some sort. I think it did some pruning. So maybe it's not all the possible paths. Um, okay, what does this look like? 46. Uh, okay, so apparently I implemented what I wanted to implement. It's just I'm not sure what I want to implement is the right thing. How does it take 46 steps when once you're 3 layers deep? Am I going too many layers deep? Because just to type to 0. Let's look at this example and oh my God. I was gonna say, let's think about this until we get to the 0. Um, but we have to translate this. We might have to translate this to think about it. Um, we can translate this programmatically. I don't know if I want to do that by hand. Um, right, left down A causes the first one to go down, right? And then left A causes it to go left and hit A, which is left. So this makes the first one go left. The first bot in. Okay, we have a better way to do this. So we can already kind of generate some codes, right? So let's say instructions. Um, and we're going to filter the ones. Actually, you know what? Let's just take a look. I was going to say, let's take a look at everything that prints a 0 and see if any of them kind of start off with this, right? See what they start with. So we have our 3D paths of 0. That filter starts with left down A, left A. Let's count those to start. How many start with that? There should be, well, at least one. That's a lot. That's a lot. We will need to cache. And how long does this get? Um, so this gets the first one to go left and down, right? And then A again to make it hit A. And here again, we have another button that's being pushed. Okay, so we can kind of see what buttons are being pushed by jumping to the double A's. AA essentially means like we ended that first bit. Let's go until there and take our count. And none even starts with that. Our first two buttons pushed. Okay, so that's a sign. It's already tired to start. It's 4:30 a.m. Am I a smoker? Why do you ask if I'm a smoker? Oh, because of the nicotine. I have never been a smoker. I went straight to nicotine. In fact, I went backwards from most people. So I took up nicotine so I could quit coffee. Um, some people take up coffee to quit smoking cigarettes, I guess. Just the pure stuff. Yep. Uh, I feel like I could give myself a nice framework to explore this. Man, how are you all still up? There are a bunch of you in like Eastern time zone, aren't there? Ugh. The problem here is that this min thing I was counting in math. I don't even remember why I said math. The minimum thing I was counting is counting in the same way as generating things. So, I mean, that's not good. Um, I think I'm failing to see an insight in the problem here. You're 21 days into a completely screwed up sleep schedule. Oh, so you get your sleep. You just sleep during the day. Is that it? Ah, okay. Up from the top again. Let's look simply at pushing zero because uh, apparently our zeros don't even appear in here. So back to the drawing board. We've got this. We can break this down. So to push a zero, right, we're starting at A. Yeah, what our keypad looks like. We're just going to enumerate them all. And we're not going to use our code that enumerates them all because I think our code that enumerates them all is missing something. So at the top level, and this is the thing, I think I'm going to have to go bottom up. I think I might have to go bottom up. Or else I'm going to end up getting the same answer, right? So at the top level, it's simply left and then A. Okay. And at the next level, there should be 4 ways to do this, right? And our code finds that pretty well. I'm just missing some insight, and I think it has to do with like going bottom up and the fact that I do go get like the minimum Cartesian distance when I'm doing the search. The fact that I'm doing that means I'm not getting all the possible paths. So I want to kind of figure out what the paths look like that are not like a minimum path. Like maybe we just figure out all paths to a thing, right? Like what if up, left? So some of these are cheaper. Like at this level, up and right are cheaper, but we have to do a left and we have to do an A. So at the first level, it's pretty straightforward. To do a left, we have 3 different ways, right? So for a left, we have left, down, left A, and then, well, all right. Yeah, for the left bit, let's start with down. Down, left, left, A, or we could go left, down, left, A, and then, I mean, even just thinking about this, A, like the right side just can be a reverse. Oh, and those are the only two options. So now going deeper in here. Well, the thing is, they both have two lefts and two downs. Right? But I guess the order of these two is what causes some differences. So at the third level, it's down and then left, left. So to hit the down, we have left, down, or down, left. So left, down, A, or down, left, A. So this is just going to match. I'll draw arrows to match blocks. So down, left, A. And then we go from down to right. And there are multiple ways to go from down to right. Actually, there's only one way. So this is followed by a right to A. So this is all to do the first one. And for the second one, we're going to have another block. So as we go from down to right, it's right A. There's only one option. And to go from right to right, it's just we hit A again. So that's great if we chunk them up like that. So we should prefer to use that approach, I suppose, right? Okay, I feel like there's some insight. Meanwhile, this left down left A, to hit left. Wait, we went down left left. So down. I think I drew a right when I meant to draw a left. So if this is for printing the down, we have two options. That doesn't matter too much. And then to get from the down to the left, it's just going to be a right. So this is down to the left, and this is left to left. We just hit A. Or actually, I should chunk that differently. So the second step is right A. Well, the second step is going to be, I don't know who I keep thinking right. So we're at the down, and we're trying to go to the left. So we do left A. And to do the second left, we do another A. And then to do the A, we have two options. So we have right, right, up A. And we have right, up, right A. So we want to choose the options that keep us on a straight path, because then we can just push AA at the lower level. Right, like this one down here, I don't think we need to draw it out. But like these are all going to be the same, and then we just choose the one that chunks them. So yeah. maybe we don't enumerate them. My cache has all of them. You don't know what to do about the sheer size of part 2? Memo? Have you tried Memo? Maybe something on my... This is for silly bugs. This isn't for problem solving. But there is this bit. Like, did I forget to memo? Okay. Let me go left, down, left. Do I even need to draw that out? I think it's obvious that this one's going to be the best. But let's see. So if we go left first, we have two options. We again have one that has them paired. So we have like a down, left, left to hit the left, and A. And then we have a left, down, left to hit and then hit with an A. And in both cases, we move to the right to hit the down, right to hit the down, and then we move back left to hit the left. And then going back to the right is the same in both these cases. So right, right, up, A, and right, up, right, A. Because they both end up going from the left key to the A key. So like this is strictly longer. And this is what I thought I was, this is what I thought I would be finding in the code that I was writing. So far we haven't found anything that would be confounding to my solution, right? Frequency map might do it too. Or like, sounds like it might be helpful for your problem. I'm not on part 2 yet, but frequency map memo. Okay, so for each of these, we do prefer, I think we do strictly prefer the ones that are chunked. Right, so I'm going to do like this entire sequence in the third level. So this is the key code. We're hitting, we're going from 0 to A. This is the first level of bots, what they're hitting. Key code, first level bots, second level bots. Oh, this is already the third level bots. Am I just recursing too much? Okay, so now we know, so this is all the options for doing a 0, right? First level of direction pad. No. First level direction pad. No, this is the first level direction pad. Hit by the bot. This is the second level, this is the third level. Okay, so for a 0, we should be having this length. Let me just go back to my code. I think I'm just recursing too much. So count min 3 deep paths, yeah, whatever. Min path 3 deep. We're counting 46 to go to A from 0. Let's go from 2 deep. Let's go from 3 deep straight to 1 deep. So let's drop a layer and see what these lengths are. So, oh, I'm not gonna mess with that right now. Let's do min path 3 deep from 0 or from A to 0. And this should give us a lower number, 18. What are the actual lengths we're seeing in practice? So you could have paths of length 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Am I still recursing too much? So we can construct this. Let's do, yeah, we can construct this with our helper methods that we have. So instruction, yeesh. For the top level, moving left and then hitting A. Left. Oh, wait. Left and then hitting A is going to be different from, we never did the bit where we hit A. I mean, I guess the bit where we hit A is simply, oh, we translated that all the way. So we just add an A on the end here, right? Well, to get 0, we go left and hit A. To go left and hit A, we go down, left, and hit A. And then we have to reverse that. Down, left, and hit A to hit the left. And then we're going to have a whole nother set of this for, yeah. So just to hit 0, I think it's appropriate. I think that number we were seeing was actually appropriate because we have to calculate the full thing. So I think the minimum path here to go 0 left A is going to be this thing reversed. So I want to stretch out this whiteboard a bit. So this part's just for 0 and for the A, or for the left. And for the A, we now have to go, since we're at the left, we go right, up, right, up, and then hit A. Okay. But I'm also thinking that that was just the issue. I was just recursing too deep. So right, up A. And to do right. Well, I guess it's going to be shorter instructions here. So let's work through this. Right, up A, and there's also going to be a right up, right A, but we're going to kind of ignore that one. So here at the third level, to hit right, we're going to do down, and then A to hit first right. Pretty straightforward. And then we hit A to hit the second right. And then to go to up, there are two options. You can go up and then left to hit A, or we can go left and then up to hit A. And at this point, it doesn't matter. I'm just going to pack this a bit. So down an A, we hit another A, and then we could either go left, up, A, or up, left, A. And then we do have to still hit the A. So we're coming from the up. We just go right, A. So that min path is pretty good. Right, this A hits that A, which hits that A, which hits the 0. So this length is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, I'm pretty confident that that's working right for 18. Um, so let's just use this min path 3 deep, which is now actually 3 deep. And count them for 0. Oh wait, yeah, full code min math. This is actually this is min path. Let's just try that. So that's the reason the numbers we're getting were too long. We just recurse too deep. 68. 68. Yeah, that's right. Cool. I had it. I had it the whole time. Great. Great, great, great. I don't know why I didn't think of that sooner. That feels like a stupid. It's gonna add it to my am I being stupid list. Where's the edit button? Are you recursing too far? This isn't off by 1, isn't it? This isn't off by 1. But it took me too long to think about whether or not I'm off by 1. I just assumed my code was buggy. If I were more confident, like I should have been pretty confident. I was testing that all along. Okay, so what's the actual problem? So for all our input lines, what does our input even look like? We get the minimum. Okay, this will take some. Geez, I lost myself. This will take a little bit of cleanup and restructuring. There's too much code here. But this will code min path. So we'll take val ans1 equals input dot map so we have a line which ends with an, we have lines which end with a, right? So number ending in a. We don't need to do it that way. This is the code. So we take the full code min path of that code and we multiply it by code dot init, which means the initial bits without the a, dot to int. And we get the sum of all of those. And that is our answer 1, 202274. Okay. Okay. Part 2. The historian is trapped in a locked area of the ship. Robots are once again dispatched. This time, many more robots are involved. In summary, there are following keypads. One directional keypad that you're using, 25 directional keypads under robot. Wait, one directional keypad that you are using, 25 directional keypads that robots are using, and one numeric keypad on a door that a robot is using. Okay. Same thing, we just go 25 deep instead of 3 deep. So we've got to optimize. I'm gonna do a little bit of cleanup before I optimize. So this is a good chance to reset our brains while thinking about the fact that we'll have to optimize that that going in deep. And it's not going to be necessarily just layer at a time. Like for every given key, I can't imagine that if we went a layer lower. Can you imagine that going a layer lower would actually make us prefer the second one where there's not two keys in a row? I mean, this is shorter only by one. And of course, on the way right might be a different story. But the thing is, left is pretty far from A. Like, I feel like we never want to have that. Is that a fair assumption? Um, we could test this with code, but it's hard to write code when the worksheet's a mess. So let's do some cleanup and thinking here. So we have the numeric keypad, we have the direction pad. I liked how the direction pad worked. We never need to reverse that. So this numeric keypad, we're gonna call it a num keypad. Do we already have a num keypad? Um, 1 second here. Okay. Num keypad. No. Great. So I'm gonna call this a num keypad, and it's gonna be a map from every character to its point location. Not that that matters. Like points might not be what I need to use here. But anyway, we have this code to get those values. You don't need this. This min numeric arrow sequences, that is going to be rewritten. This show might not be necessary anymore because we're not going to use directions. There are key paths. So that's dir paths, and here's num paths. We're going to implement it in kind of the same way. The only difference really is this filter. What are you filtering by? Dirpad2 equals precision into. So let's pass in a keypad. So we get all the paths from 2 given a keypad, which is a map from character to position. Okay, so we have a num keypad. Let's have a direction keypad. And we use a state. To get the next bits, we could inline that. this filter, this inbounds check. You could give that a name. But I think I'm fine with that. Like this is pretty self-contained. So now we have dir key paths and num key paths. We basically do paths from to 2 using the dir key pad. And then this one, we have the same code. And I'm wondering if maybe at this point I shouldn't just have a single answer for each of these. Like we prefer not to change direction. Like we obviously prefer not to change direction, especially at the top layer. Right? So people are implementing min in that way. It's just a choice between like, do I go up, up, up? Let's say I'm hitting 8. Let's think about that real quick. I'm hitting 8 from, 3 or something like that. I don't know. Do we even have that? Hitting 8 from, but yeah, let's suppose for a second. Then we have a preference over going up, 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 left. So to go from A to 8, the first set of instructions is going to be either up, 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 left, A, and then we end up doing down, 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 right, A anyway, or maybe right, down, down, down. But anyway, the first set of instructions is either that or left, up, up, up. We're just going to group them. Still going strong and hard. Thank you. I am so not hard. I've got a soft, squishy brain. I mean, it's supposed to be soft and squishy, so maybe we're in a good spot. And then, we have a choice of, well, we don't know what's happening next, but to go from A to 8, those are 2 options. Could one be better than the other? Well, to go up, 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 essentially we go left and then A to hit up, and then 3 times in a row, right? I think this is kind of insight I missed. The insight I missed wasn't necessarily that there would be different, different paths at lower levels, but what those different paths would look like. It didn't occur to me to think about this. Like, it might not even matter as long as we have one way of doing it. Like, if it turns out that these two are always going to be equivalent, then we could simplify our algorithm like a lot. Okay, so we hit up 3 times, and then we have to hit left. So from up to left, it's going to be down, left, and then A. And then we have to hit A, and for that, we want to go right, right, up, A. But now if we're going down the other path first, the essential difference here is only the order of which we're going with these. So we go from A to left, A to up, to left, then back to A. Yeah, A to up, to left, and back to A. Is that different from going A to left, to up and then back to A. I don't think it is. I think this is literally the only thing that causes any differences. It's the chunking. You know what? Since that's so much smaller, I'm tempted to just. So this is our cleanup. We're starting a new worksheet. I am tempted to write our caches just manually. We'll just have one way to do it for everything. Oh, wait. But you have like from a direction to another direction. I just want to take another peek at this. Let's draw it out just to make it obvious. So we're heading up first. Now if we're heading left first, you want to go down, left, and then we hit A, right? And then to hit up, we go right up, and then we hit A, A, A. And then we hit right and hit A. So there's still the same number of A's in each of these, right? So we can ignore the A's for now. Left, down, left, right, up. Left, down, left, right, up. Or we go down, left, right, up, right. Yeah, it's the same thing. Of course, it's the same thing. Let's continue this refactor, but I think we can simplify, which will be nice. So our start is going to be our keypad from whatever keypad we pass in. Val, and let's also give ourselves no, that's a start state. Let's give ourselves start pause and end pause. Copilot can join me here. Oh. End pause equals keypad 2. Okay, when we iterate, we start at our start pause. Our next, we want them to be filtered chunked. We're gonna mess with this a little bit later, so I'm not gonna bother cleaning that up right now. But all these keypad 2 references and keypad from references. So start pause distance to the end position. If pause equals end position, then we return that path. To do make singular. And dir keypads goes to a list string num keypads. Right. Let's just make sure everything else we had previously works while reviewing what we want to keep. Key code instructions. I do kind of want to rename this. This I mean, ultimately, we didn't really use this. I mean, like we use this for debugging. But this isn't the way we wanted to approach it. Just creating the whole thing, because we just go straight to counting, and that's fine. Yeah, it's turning out to be a little bit of a long stream. Hmm. Are these all passive aggressive comments? No, I'm taking them as cheers. Look at that, he's still going. I think I've got it though. So if there was a time to tune in, it'd be now because I know what I'm doing. What am I doing? Um, what was this thing here? Numerics. Um, okay, all these things I was doing. You're happy about yourself? Okay. um, so all of these little bits that keep ending up in places, I think need to be functions. I think I'll tear that up elsewhere because that code appears elsewhere. Oh, there was this. This is our code. This is our code that works. Um, but I want to break it down in a different way. Of course, just recurse using numbers. Full min code path. Full code min path. I think we just call min path a depth. So def min path depth of robots and then code. Oh, Snow. Hey, raid with 107 viewers. Welcome, welcome, welcome. All right. How's your stream going? Are you caught up? Good to have you all. You have a fun stream. Um, have you gone to 14 part 2 yet? Because that's a fun one. Finished day 17. What was 17? Wait, 17. 17 is a fun one, right? 18 and 19 are the break days. 17. Oh, day 17 was so cool. How'd you like it? I only come out one time a year. What's up with that? Uh, well, the one time a year I come out is Avnet Code and Eric burns me out. That's what's up. I have to spend the rest of my life recovering. That's the problem. Hmm. But seriously, this day 17 part 2, this is the kind of stuff that sets Avnet Code apart from code. And like the day 14 part 2, like these are puzzles where you have to you're not just told what to do. You have to figure out what even you're going to do and then how to do it. And then reverse engineering this was pretty fun. Um, I I like over modeled this, but modeling it was fun. So toxic. Who's toxic? Okay, who's talking shit? Day 17 I started doing manually. Honestly, I think starting off manually would have been the way to go. Like even part 1 you could just do manually. Right, like you decompile the code and then you understand what it's doing. Write that code yourself, do it, and then just Honestly, I think day 17, we could have done pretty well with pen and paper. Because so I wrote this big class. Um, but it took a while to do it, right? Like the whole point of this is so I can get this next function which progresses me. We match in the opcode, do our operations, and I do like how it turned out. Like it's clean and easy to read and debug. And then I have helpers to just run and get all the output and whatnot. But writing all this did take time. Like that's a lot of code. Like it's great when you're like going through and debugging a machine and whatnot. For part two, I didn't like do it all manually. Like I understood what I was doing, but all I needed to understand really is that you can shift 3 for each step and then check that the state moves from in the way you expect. Snow actually became a computer to solve day 17. Awesome. You can do pen and paper if there was no C register. What's happening to the C register? Oh, yeah. I mean, I started doing that anyway. Let me show you my whiteboard. Uh, where was I doing that? I spent. Is it here? Anywhere? Over here. Yeah. I spent some time like whiteboarding over the C's. And as I was doing this, I was like, I could just do this all the way. Um, so no shame if you felt like doing it with pen and paper. There have been a few in the past years that I there's one that I solved 2021 day 23. I just straight up solved part 2 pen and paper because I was struggling to get my search to work properly. Microsoft Whiteboard. I hate Microsoft Whiteboard. I need a better whiteboard app. Someone recommended a different whiteboard, but if anyone has recommendations, please. This is it's trashy. I don't know. It's hard to work with. That's what you were doing. Then you realized some paths failed, and you had to use programming. Excalibur. Okay, Excalibur was also recommended earlier, so I'll have to give that. I'll have to give that a shot. But I mean, I do enjoy drawing this. Last year in particular was a very kind of drawing heavy year, and I had fun with those drawings. Like my whiteboard by the end was like I wouldn't say a piece of art, but it was a piece of memorabilia. You can do it with no account in the browser. Does it work well with a pen tablet? You use a Wacom tablet, right? Honestly, I want to get a better tablet too. But I don't draw enough to super invest, I suppose. Um, yeah, anyway, day 17 was fun. Day 21 is still being fun. Fair enough. Um, or day 21. Yeah. We got part 1. And sorry, but there are spoilers here. Let's go back to the whiteboard. I'll tell you what I'm doing. Um, and I did have a search that worked fine. And for the longest while, I was just debugging because I was iterating too far. Okay, sleep well. Catch up on your sleep. Hope you had a good stream. Mm. Honestly, yeah, it's a very troll problem. Um, it's definitely a fun problem in concept. Okay, big spoiler here. The insight here is that um, the only real way you can change the length is by grouping these together, right? So like you can search over all of them and you can do some caching and do like the minimum at each step or whatnot. But at each level, you don't really even have to search around. I think you can just group them. So I was formally generating like lists of paths. And while I think I could optimize the previous approach, I just want to go to a point where we're only generating one path for every pair. And in this case, there's like up, 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 left, left, up, 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 A. I think my suspicion is that these are equivalent. I don't know that I've proven it exactly, but I think either of those. Well, okay, we can do kind of a pseudo proof here, right? Whether you go in this chunk, then that chunk, then that chunk, you are still going to follow a path, right? You're going to start at A, and you're going to go two down. You're going to have a favorite way to go, or two like left, and then you're going to hit the up, and then you're going to go back to the A. Or you're going to start at A, go to the up, go to the left, and go down. If you have favorite paths for everything, then you can choose a favorite path here. And it's just choose a direction, right? So I think I'll just prefer to go, uh, well, I'm going to do that based on these keypads and where everything. I think if you always go up and down first, and then you go left and right, then you won't end up hitting these empty spots. Yeah, so that's what I'm gonna do for my new caching. I'm gonna cache everything in advance. Um, and this is my, let's see, this is my full calculation. I need to make this actually recursive. But before I do that, we're gonna save this as part two because I do want to scrap most of this, but I might regret scrapping some of it. Um, yeah, and I'm just gonna make sure this whole thing's commented out so that it's not showing up as errors. Um, so we were using this paths to make caches. So given a combination of characters going from one to another character, what are all the paths that you get there? Um, and well, like that can still serve us because it's a tiny cache. I just want to change that to string. Yeah, and to do that, I can change, I use this generic function here that applies to both keypads. We have a num keypad and we have a direction keypad. We pass that keypad in and use it to find a minimum path. So we just want as straight a path as possible. So here we also go to a string instead of a list of string. Paths become singular. Let's just rename this. Oh boy. And we're just going to delete everything else because I do want to write that. A lot of this was exploratory code anyway. Great. So we iterate from, I'm not even going to have this anymore. So we have a start position, we have an end position. And we are going to iterate from our start position. But we have like a path so far, I suppose. I suppose we keep the direction. Mm. Okay, so we have a position and then we'll have a path. So our starting state for iteration will be start pause, and then we'll pair that with a path which starts with just an empty string, right? So at each step of our iteration, we have a position and a path. I don't want Copilot in here, so we're going to disable that. And Nyansai, thank you for the follow. So for each position, if our position is already towards the end, let's see. We're going to check if we're on the same horizontal line. So we're just going to go vertical and then horizontal. So if pos.x, no, y value. So they're on the same horizontal line, pos.y equals and pos.y. Then we iterate horizontally. Otherwise, we iterate vertically. I suppose if n pos.y is greater than pos.y, in fact, I might put my horizontal iteration here at the end. So let's start with this as our first if. Then we move pos up. So pos goes north. And then we add an up arrow to our path string. Pretty straightforward. And then we have an else if pos.y is less than, hold up. No, we already have, let's say it's, if our goal is above us, okay. And if our goal is below us, oh boy. I think I'm mixing up my y up is decreasing. I'm going to take a quick detour here, and we're just going to add this to our point library. So comparator between 2 points, because I don't want to be, right now, I don't want to be thinking about directions and numbers or whatnot. That feels very error prone to me. So let's see, def above another point. So the other point, p.y, should be less than this.y, right? And we'll just implement below, that below. And at this point, we can just let Copilot autocomplete that. Left of and right of, great. Great names. Good choice, Copilot. Okay, great. Now we don't have to think about that math in here. So if end position is above our position, and actually we can just use this syntax, above position. We'll make those infix methods. Okay. Otherwise, if end position is below our position, then our next position is south, and we add v to our path. Otherwise, we check for left of and right of. Copilot has got the idea. Great. If left of, else. We're gonna make this an else if right of. and position is right of position. And then in this else, I'm just adding this so that I know if I made a mistake here. So that's just going to throw an error. And what are we going to do? We're going to take steps dot take while. Well, we want the step for which, so we're going to find the step for which we match the end position. So that works. We can refactor this to there's a nice way to refactor this, but I think it's clean enough to read, and we'll move on for now. I can do that later. And this is this underscore 2 is our path. These underscores are like tuple accessors. So if the position is in the end position, then we get that path. Okay. So now we have our new caches. Index seek. Oh, we gotta make a string out of this. No, that's already a string. What's actually going on? So path here gives us a string, and then we map on that string. Oh, right, we don't map anymore. So we just add a onto the end. Yeah, and then we have order of operations. So we got to put in some parens. Okay. I mean, for those of you just joining, this is as if I'm doing part 1 again, because this this solution is essentially the same as part 1. Yeah, we're writing from scratch. Seem to have issues here. Cannot prove that point to character. Oh, we've swapped this around. I think we do want to have a character to a point. So we're going to swap those. Okay. Now, I don't like that's trying to autocomplete from my other sheet. We have other issues? Nope. So to get our answer, hold up. Is there or is there not a problem? It's out of memory. Out of memory. So when we're creating our cache, that's interesting. That's out of memory. That tells me there's a bug because we were able to create a cache just fine when we were doing full on list of strings. So direction keypads, like these won't be all that big. There's like 20 combinations. Okay. So I suspect then in here we are recursing too far. So steps.find. What were we doing? We were like either going up or down or left or right until we find the end position. So if the end position is to our right, then we move to the right in this step, right? Otherwise, move to the left, south, north. So when we're trying to find it, we are going too long. And how might we be going too long? Um, okay, in a situation like this, maybe I do that refactor I mentioned earlier. Um, because that'll just give me a chance to write this correctly. There doesn't seem to be much debug in here, does there? Like we could pull this outside and give it a test. We should print the steps that we're using. I don't know, so this dirt key pass doesn't get that long. So let's see what's happening before we try to find. Let's do steps dot take 10. 10 is plenty. Dot to list, and let's print that. Okay, so what did we end up printing? An implementation is missing. Oh, wait, we're not getting an out memory error, right? We're just accidentally getting all the way to the end position. Right, we forgot to guard against that at the start. Okay, I see what's wrong, but I still would like to refactor this slightly. We're going to use an unfold. So with an unfold, you have your return type, and then you have some sort of state. And our state is just going to be position, because we don't actually care about returning that position at the end. And we're going to return a bunch of characters. At each step of this unfold, we're going to return a character. So our state is just start position. And we decide to continue as long as we're not at the start position. And then we output a new thing. So I'm going to say option.when. I guess we have position. When position is not equal to end position, then we have a new position to output or a new direction to output. So val direction. It's going to kind of copy this if else branch. So okay, so if end position is above, then at this point we just return a character, right? Let's actually use a direction. So we'll do direction.north. Else if, and let's have Copilot complete this. Okay, and this case shouldn't happen, but I'll leave that there as a test to myself. Now that we have our direction, what we output is going to be like a string or a character. So dir.to, let's see, we want a way to print the direction. So val dir to character. So just going to be that map. So dir to character is what we're outputting of our direction. And then we pair that with our state, how it's progressed. And that state gets used in the next step. So pause that move in that same direction. Okay, that is much nicer. Okay, so now that we have all of our steps, and since it ends when we hit the end position, right? Yeah, we can take those steps that make string, and that is our solution. Make string out of all of those characters. Okay. That also seems to be running for a while. So maybe our termination condition is not exactly correct. So let's do a quick print steps dot. Let's just have this return. Let's just have this return the steps for now. Lazy list of direction character. Sure. And see if it's going too long. I don't know why it would go too long, right? If we hit the actual position, shouldn't we be erroring out here? We should be erroring out here. But let's test anyway. So let's go from a character. I don't know what our keypads look like. Hidus, thank you for the follow. Okay, so let's say, we go from A to 5. That will involve going up a bit and going left. So path from A to 5. And let's just take, so that shouldn't be any longer than 1, 2, 3, 4. So let's just take a little bit longer than that. Take 5. And then make that a list. Let's see what happens there. It's 6 hours. 6. It's not 6 hours. Okay, you know what? I'm determined to finish before 6 hours. I'm not gonna be at 6 hours. I know the solution now. This is just a matter of writing the code. If I can get over the bugs. Advent of no sleep. I mean, why are you all still up? How many of you are, say, in like a European time zone? Or who is still, what would be the craziest time zone to have started? I think Eastern US. Eastern US is, you're close, you can feel it. I can feel it too. I feel like we're both close. I mean, if it's Eastern US, you're at 6 a.m. So anyone who's here from Eastern US, I feel ya. I've got respect. Wait, what was the error here? Did it? I don't know. VS Code has been kind of like just shitting the bed lately. And when that happens, I have to restart it. Michael in the Eastern time zone. I don't feel like this is that hard. I don't feel like I've been stuck conceptually at any point. I'm just a big brain fog. Sleep. Imagine adding a code where you had sleep. Yeah, but like what I've been struggling is just implementing like the basics. Okay, like I don't know. Maybe I'm overconfident, and maybe I don't know what the solution is. It just takes me a while to write it from scratch. Okay, what's going on here? It's failing to compile. What do you mean declaration methods aren't allowed? Oh, we're missing an equal sign here. Okay, is this what made VS Code crash? Okay, whatever. Okay, so path from A to 5 using the keypad. What keypad? The num keypad. Okay. This should fail, right? If it goes too long. Take 5. No, it shouldn't fail. It'll just not draw that many. Found a unit. Pause that move in a direction. And we required a lazy list of characters, right? We're just going to return that directly. Okay, so num keypad, A to 5, we're getting V. Okay, I'm not going to do direction to character. We're just going to return the directions raw and see what we're getting. SSSSS. So from A, we're trying to go south. We're going in the wrong direction. Okay, so if end position is below that position, then we go south. Okay, well, what are these positions? Num keypad for A and num keypad for 5. Where are those? What are my coordinates? Actually, let's do 6 because it's directly above A. You're gonna sleep on it? You're calling it a night? So we're at 2 or X for each of these. Well, good night, Icy Black Deep. Good push, good push. When you wake up, you'll probably get it right away easily. Sleep works wonders. Okay, so 6 is at 2, 1, right? 2, 1. And we know it's above because its y value is less than A, which is at 2, 3. So let's look at our above function. I'll just implement this backwards. We are above if p dot y is less than this dot y. We're above p. No, we are above p. If our y is less than p dot y. Right. Okay. Copilot, get another chance. See, that's a problem. I seeded Copilot with the wrong thing, but at least it's consistent. It was consistently wrong. Okay, let's just check the x's. So p is less than x if our x value. So let's say this is us. Man, I struggle with these bits in particular. This is why I try to put library code. So we are left of this point is left of that point, P, if this x is less than that point's x. Yeah, that looks good. Okay, so now this is north-northwest. Perfect. And then we want the path string. So Val, those are the steps. We're gonna take steps.map direction to character, and then we're going to make a string. Okay. I like that. Um, we have a compilation error somewhere. Recursive value somewhere needs a type. I don't believe that. Where's our recursive value? Oh, okay. Indentation, significant indentation. Okay. Great. So that looks good. We're finally set down the groundwork. So worksheet.sc. Yeah, that's a Scala thing specifically. So a normal Scala file is .scala, and then you'd compile that and run that in the console. But in this case, I have a worksheet so it just outputs things to the right as I go. It's particularly it's a metals thing. So metals is the name of the language server protocol implementation that I use. So you can use the same worksheet thing in Emacs, or Vim, or whatever. Um, Great. So we have our paths. Do we remember how to solve the problem? Um, I guess if we just have a minimum at this point, we just go all the way down for each character, right? And we have everything cached. So we just generate a path and we're good. And we get path length. Maybe I should just cache path lengths. No, I can't do that. Was this triple question mark? That throws an exception. So like the implementation is actually just throw new not implemented error. And since it's a nothing, that's the bottom type, you can place it anywhere. So it's handy. It's handy every now and then. So it'll always type check. Okay, so we have our paths. Def. I guess we have the path for a code at a depth. And I think I want to write this in such a way that I think I want to take advantage of further memorization. So code string depth int. So I'll write top down for now from our final answer. But I think the part we want to memorize is the direction pad. So this is the key path. Yeah. We're gonna call them or num path. We'll call this the num path. And this will just give us a string. I don't know what this autocomplete is. So let's cancel that. So for each pair of these, we have a start, we have an end. So we're gonna zip code with itself. Not the tail, because we're gonna have a leading phantom A, which is our original starting point. And for each of those, we want a key path, right? Or a direction path. So this is a case from and to. From and to on a num keypad. Great. This is if we're doing this at a depth of 0. So I think we do need to enter. Let's ignore depth for now. And once we get this path, let's do this +5. Where the hell did that come from? Okay, Copilot, you're drunk. So we get the lowest level of path. Actually, we want the cached thing. No, we don't actually have that cached. Wait, what do we have cached? Are our caches missing? Ah, yes, before you do any of this, let's cache all of that. Okay. So, Val, what did we call our caches before? I liked the names we were using. They're keypads. Okay. Yeah. So this can be a map from a pair of characters to a string, this kind of thing. So these are all the possible characters for this keypad. And this is basically, yeah, this is copied over from my other worksheet. So we take path from to using the dir keypad, and then we add an A at the end. And just to shorten this up a bit, we're gonna put the type here. Okay, and val num keypads. And again, this is now singular. And what's going on here? Oh, we need parens. Okay. Great. So we had that cached. So this is how we do it at one level. So we're just going to map each of these tuples through the num key path. So this is one level of recursion. And let's just test that real quick. Num path 1, 2, 3, 4, 5. Sure. Great. Now let's make this recursive. And how do we make it recursive in such a way that we can also memoize? Well, that would be at the direction path stage. So def dir path, let's do that first. And I guess in this one we can just we're not passing the whole string down here. We're taking pairs. So the direction path from some number to another at a certain depth. So from character to character at depth int. and we get a string out of this. Okay, so we take the, wait, what is this? That's Copilot. I mean, this is what we would do if we were just going down one level. So let's put that like in an if else. So if depth equals 0, at this point, we just return the normal thing, the dir key path. From and to. Otherwise, we still need to do this, I suppose. But then we destructure it and call dir path on each of them. So yeah, we call it dir path recursively. So we still take this. I don't know where that take depth comes from. I'm turning Copilot off. So otherwise we take this and now we get a new path which we need to destructure. I wonder if I shouldn't do this at the level of, I know, val path equals that, right? And then we're gonna do similar thing to what we did here. In fact, I'll just copy paste that, change code to path. And then we use dir key path instead. This num key. So when I, right, this just takes pairs. This takes pairs. I was wondering if I shouldn't just take this whole string and pass it down. But anyway, we do this thing again. And then within this, we recurse with the lower depth. So this gives us our new sets of from and to. So we're not going to map dir key path. We're going to map dir path. What do we have? We have like a from and a to. Let's write this way case. We have a new from and a new to. And dir path. From to depth -1. Okay. And I think this is the part that we want to memorize, this dir path. So def or val memo, we're going to use a mutable map. And I guess it's from a pair and a depth. We're going to memorize with a pair and a depth because horizontally, this can be happening a lot, right? So we have a character, and an int. And that goes to a string. It could go to a length. Yeah. we'll do length. So dir path length. I don't want to be like building the strings really. I don't care to build them. So at the lowest level, at the base case, when our depth is equal to 0, we just take this and we take the length of that. So it's the only time we compute the length of a string, of an actual string. So we're not going to construct strings. And that memo, we could seed it. We could seed it with this, but I'm not going to bother. So memo.get, or this is gonna be our calculation. So we'll put in lazy val. Lazy val calc is this whole thing. Nah, do it that way. And then we're going to do memo.get or else update. So our key being from to depth. And the default value is to calculate it. Okay. So let's do numpath length at some depth. So we have a code and we have a depth. Oh, we are not going to finish by 6 a.m. But I mean, we are well on our way, right? We're moving along smoothly. I don't think we're stuck. And this returns an int. So it's going to be similar to this here, except we hand off to dir path length or a bunch of froms and twos. So we have the path we're trying to construct. Well, hold up. Map numkey path. So for each pair, for each pair of numbers, right, we get that particular path. We string that all together in one. And I'm happy sending this whole thing down. Like, you know, there's no real case for memoizing here at the level of the nums. So we take path and we do the whole sliding thing. And then we have, when we do that, we're going to have all these tuples. So we're going to have a case from to, and this is where we recurse into dir path length. And we will pass in the same depth. So we have the from and the to and the depth, because say we have 25 robots, we're sending 25 robots down here. The Pirate Roberts, the Dread Pirate Roberts. Hello. You just getting started with adding the code? Oh. Or ending. Wait, what's going on here? We haven't finished writing this. So dir path length. And then we just get the sum of all of those pairs. Okay, we get the length for each pair of, what's this, arrows? The arrow key things. Okay. Is this Kotlin? No, Scala, exactly. Does it look like Kotlin? I haven't worked with Kotlin in a while. But this is Scala 3, so it should look distinctly less like Kotlin and Java. It looks closer to Python. I'd say. At least the way I'm writing it here. It is better, Kotlin. We know what's up. I know Kotlin community is pretty big about doing their advent code thing. I see their videos pop out on YouTube. Hmm. Okay, we have some compilation errors to fix. Wait, what? Map.empty. Okay. So we have our memo. Dir path. I think I meant dir key path. Isn't this a great error message? I know, like it should be. It should be par for the course in 2024, but it still tickles me to have suggestions for variable names. You're still not taking the shortest path. Oh no. What if I made a wrong assumption? If I made a wrong assumption, I'm gonna go to sleep at 6:30 a.m. and I'm gonna bolt awake at noon and be like, "Oh my god, I solved it." uh, okay, we get the sum. Wait, what's going on? So compilation errors to fix. So dir key path. Um, what are we doing? No, we meant dir path length. Dir path length because we are recursing from 2 in depth minus 1. Okay. And here, otherwise we do calc. Calc is an inter-index seek. So this should be coming up as an int. So where is an index seek possibly coming from? Oh, here. Map, we forgot to take a sum. So for each of these pairs, we get those lengths and then we sum them up. Okay. Now, a moment of truth. Let's make sure this still works in part 1. Otherwise, I think it should work at least on part 1, right? Like if this optimization doesn't work all the way through, then something crazy happens the deeper you go into this, but I can't imagine what. So let's do one path length for our code 029A. Let's start with 0. So with 0, we have one of these 3, and those are of length. Did I even have these in here? Okay. It does not want to paste. Why is inspector up? Okay, we want the length of that. So the first step, we should have 12. So 029A should be at a depth of 0. 28 is the next level. So we have the same issue. We're going too far down. Oh, I see. We're counting this separately. Here we're directly going to dir path length. I mean, I suppose in that case, if it's 0, we'll just skip that, knowing so 0 means 1. Okay. Yeah, we're gonna just gloss over that. We know that the next next one is 28. Why fix the off by ones when you can just make your input off by 1 as well? Okay, that one. And that, so for part one, we did have something that's shortest length, 68. Wait, did we skip a step? No, this is 2 already. So, this is the, we need to type 029A, and the robot needs to push this, right? So that's one level. And then this here, let's get the length of that. That's the next level. It should be 28. Okay, so we go from 12 to 28. And how are we numbering them? So 12, I guess, is the first robot. So the first robot is like -1. The second robot is 28. If we have 25 robots, so this is our 3. Okay, balance. Am I really not going to correct that? I think so um, because I want to get the answer. I want to make sure this works first. Now ends 1. Okay. This bit here. Don't bother. F this question. I feel that we've come so far. We've gotta do this. So this is a path length of code at a depth of 1 times code init to 2 ends. Okay, let's see if we still get our part 1 answer. 202274 was my answer. I got something shorter. I'm missing some A's. That's probably what's happening is I'm missing some A's. But at least we know the recursion depth is off by 2. How'd it go from, okay, whatever. So ends 2 is going to be that, but it's going to be at 23, right? Okay, and at least it's fast, but we have an overflow. Because we need to take this and do numpath length needs to return along, actually. Dir path length should also return along. I think that should be enough. Okay, calc, our memo needs to store logs, not ints. Okay, so this is performant enough. Let's just fix this bug with missing A's. No, we don't appear to have missing A's. So this worked for 28, this worked for 68. 25 directional keypads. Yes, that's what part 2 does. Wait, there's one directional keypad that you are using. Okay. Okay, so there's gonna be an off by 1 there. One numeric keypad on a door that a robot is using. So if our depth is 0, then off by 2 makes sense, right? If our depth is 0, we're still using this keypad on the door, and because our numpath length is automatically going to dir path length, there is the robot. So that's step one, and that's at one. So actually saying 25 would be correct here, right? Yeah, putting in 25 would get us our answer. I don't know. Do they have a test for us? So I can't check the order of magnitude that way. Okay, we'll think about that in a sec. Right now, we do need to fix this, our part one answer. 20274. Like 202,274. So we're missing, let's just subtract that, our original answer, 20274. Comment out ends 2 for now. I want to know how far we're off. Wait, what? 202,274. There we go. So we're off by 116. Let's examine these maps. More importantly, I think the stir key path map. Stir key path for each print line. Let's take a look. Okay, to go from left to down, yada yada. To go from A to A, we just push A, right? We push A at the end. There's A at the end of all of these. To go from right to down, right? To go from right to down, we push left and then we push A. To go from left to A, we go up, right, right. I mean, it is equivalent. It is equivalent, but it does go out of bounds. Should it be equivalent though? Because instead of up, right, right, we could say right, right, up. Are those going to be equivalent going further down into the list? Because you still have to get the minimum for the up. Okay, how about moving? Okay, up, right, 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 up, up. Moving from right to up. Either we go from A to a group of rights to up to A, or we go from A to up to a group of rights to up. It might be I want to tear that apart. So going from left to A. I want to go down in another level and just verify to myself. Right? We either go down and then left up, or up left, then right. Right? Those are the only movements happening. Down, left, up, right. We go left, down, right, up. We have an option not to use some of those. So yeah, let's list them out. So we're going from left to A. Let's use a space, draw it out. So going from left to A, right? And we had the situation where we did end up going out of bounds. And my hope is that doesn't matter. My first implementation avoided that because I just went through every path that was possible. So up, right, right is the path we end up taking that we don't like. And then A. And the path we should take is right, right, up, A. It is. It kind of messes with your head, doesn't it? Okay, so to do each of these, to do the up, we're going to go left and then hit A. And then to do the right, we can go down right. Yeah, we have two options, down right, right down. So right down, and then A, or down right A. And again, this corresponds to this whole block, corresponds to this line. And then so right, right, and we hit an A to hit the second right. And then we have to backtrack to the A. So from the right, we just go up and hit A. Up and hit A. So if we go up first, that happens. Let's see what happens if we go right first, which is the correct thing. Or the robot freaks out. So if we go down to the right, well, we have down, left, left. As the only option we're willing to consider. We could go left, left, down. I'll just write that there, but cross it out. Can't you drop all paths with something onto... Drop all paths with something onto A. Why would you want to do that? I'm not sure what you mean. Drop all paths that have something and then A. I mean, I'm still writing the A's because I'm counting. So we go to the right, and then we hit it, and then we hit it again, and then we go from right to up. Wait a second. No, no, no. Right's not there. Let me erase. Numpad layout. Yeah, let me scroll up just a little bit. There we go. So, think about this again. So we go from the A to the up. We go left, hit it. Then to get to the up, we can either go... Wait, we move to the left, hit up. Then to go to the right, we can go right down or down right and then hit A. We hit A again. And then we go up and hit A. Now, if we are hitting right, right, up A, we go down and hit A. And then we hit A again. And then we go up. We go to up, which means we either go left, up, and hit A, or we go up, left, and then hit A. So I think there are other cases where order might matter a little. Then from there, we go right and we hit A. And what we want to see here is that's not really the same sequence of characters. I'm hoping to see that because that gives us a, well, it's the same number of characters. So it's going to be the same number of characters. But do they involve different things? So left, well, in the above, we either have left, right, down, up, right, left hit the up button, down, right hit the right button, and up. Or we have left, right. No, we just left, down, right, up. And I guess those two could matter. Left, down, right, up. One of those could require more movements than the other. Yeah, but how far down do we need to go with checking that? Do we just need to go down to the next layer? That's my assumption for now. Like, I still think it is a fact that you want to group, but you want to choose like the one true grouping. Which, I mean, for the numpads, there's only gonna be one way to do things. I mean, from A. Actually, I mean, you could, well, yeah, you can be choosing different directions, up, left. Okay, so does it matter if you go in a circle or like you reverse? So to hit down, when you go down and back, to hit down, there are 4 different ways, right? Um, one is one way better. The only way to find out is to break this down. Left, right, down, up. So to do left, right, down, up, we go down to the left. So we have 1, 2, 3 movements there, and then all the way to right. So 1, 2, 3, 4, 5, 6, 7, 8. But now if we do left, down, right, up, so 1, 2, 3, 4, 5, 6, 7, 8. It's still the same number of movements on the next level somehow. Let's break those down. Oh, these are just the options for the top. Left, right, down, up. Which, I mean, the top one's not even legal, right? For going from left to A. Yeah, we can't even go up. So let's quickly break this down for the bottom. There should be a faster process now. So we have down, and then we hit it twice. So we move down to get to the right, and we hit it twice. And then you go to up, which there are 2 ways to do that. We can go left, up, and then hit A. Or we could go up, left, and hit A. And then from that up, we need to go to A. So we just go right A. Um, and did we really have a choice of options here? I mean, okay, certainly like, wow. Are we seeing that one is clear? So this is 1, 2, 3, 4, 5, 6, 7, 8, right? Either of these are 8. 1, 2, 3, 4, 5, 6, 7, 8. But at the next level, we have down, hit, hit, and then we move twice to get to up, and then we move to get to A, and we hit it. So 1, 2, 3, 4, 5, 6, 7, 8. It's still 8. That makes sense because we're hitting the same characters, we're just hitting them in a different order. And this is why I think it doesn't matter. But does it result in different patterns on the lower level? So is there another way to do this? No, we kind of just go down. There's no real choice. To get to up, yeah, we have these two choices here. Just like we had these two choices up here. But for the first move, wait, for the first, left. Oh, wait a second. This thing, I already wrote it here. Okay. Okay. Since we wrote it again, I know. I'm gonna erase the one in the middle. Yeah, we basically have those two options. Let's break down those two options. Like I counted them as being the same, but I'm not sure. So if we're going from left to right, I mean we're starting from A in any case here, right? And you go left to right and then down up versus left down, right up. Okay, to hit the left key, we can move down, left, left, followed by the right key is right, right, followed by the up key. Let's say up, left, or left, up. Either way, it's still 2. And followed by the down key. Right, this is left to the right. No, we have the down key next. My bad. So down key is always going to be to the left. So to the left, and then the up key is going to be up from there. So 1, 2, 3, 4, 5, 6, 7. And then this lower one is going to be, we still go to the left. So down, left, left. And now we go down. So we move right. And then we hit right. So we hit right again. And then up is either choice of up, left, or left, up. And it is the same number of keys, but do one of these have longer groupings of keys? So this essentially becomes left, right, left, up, if you're just grouping. And the bottom one becomes left, right. And it's like up, left, or left, up. Why does one of them have choice and the other one doesn't? It's because we're moving across this diagonal, I guess. So left, down, right, and to get to the up, there's a choice. But if we moved in the other direction, left and right, then down and up, there's not really a choice. Um, anyway, where were we? Um, man. Left, right, left, up. Just all the directions. Ah. So this is what we need to do to implement this pattern. This is what we need to do to implement this pattern. And this, if we go, I think I was following where we'd go to do those blocks. Right, this block is essentially down, left, right, left, up. This block is down, left, right. And we have two choices, down, left, right. Yeah, these both start with a V. So we're just removing all the duplicates. So we still have like 5 different characters in a row and no apparent opportunities for grouping, right? Like we could look at the list of characters and look if any two result in grouping. I don't know, if we went from left to down and then down to right, do we ever have the choice to go from left to down? Because you often end up circling back to the A. So no matter which path you choose, they are going to be this joint, right? If you go left down and then upright, yeah, if you go left down, upright, any of these, you end up making the same number of movements, and each movement's going to be in a different direction. They're not going to clump. Unless maybe you had a choice where well, I mean, they're not going to clump because there's going to be A's, right? So like down left, A. So even if you're going from here to another left. So if you're going to A to down to left, you can go down left and then left after that. But after you hit that down, you have to go back to the A. And then you go to the left and then go back to the A. So that clumping doesn't matter. I don't understand why this optimization works. We could at least make that bit correct. But I don't think that's the reason that this works. I don't think that this bug here, where I do choose to go outside, is the main issue. Because I think at least that case should be equivalent. It has to be an issue. It has to be an issue. I just don't see how it's an issue. Okay, when we're moving around keypads, this code needs to be a little bit more complicated. Yeah. Okay. So I think we were choosing to go north and south first, regardless, and then go left and right. Um, but before we do north and south, the problem is now I don't know. Let's say we're going A to 5. I don't know if you want to go left and north or north and then left. Again, let, us play this. Let's say we are going to A from A to 5. Um, so on the keypad, you're hitting left some number of times, right? Like you go to left. Um, and you go from left up to north. Ah, this might be the only part where it matters actually, is here in the numeric keypad, because you aren't always going back to A. For the direction keypad, you're always going back to A. Okay. Um, there's a thought there. I think we're onto something here. We have to think about the order in which we do these. So we can just optimize at the num keypad level. And the dir keypad, I don't think matters. But I'll rest on that thought while I take a quick break. Righty. What's this? Right, right, A is never allowed. Um, what do you mean? You will never push right, right, A. Yeah, that's true on the keypad level. On the direction pad level. But on the numpad, you could end up with 1 and then 3. In which case on here, you would push right, right, A. Right? Um, let's think about this keypad again. Um, and let's say you have a 6 followed by, or a 5 followed by a 4. Does it then matter whether you approach 5 from south or from here? So on this keypad, you're pressing left up. So if we're going from the south, we're doing left up, up, and then we do have to go back to A. And then we go push left and A, right? So left, um, just looking one level, left, up, up, A. I think at lower levels it stops mattering so much because there are so few options and you're always hitting A's. Um, so left, up, A, and then you go left, A. If you're going from the right, you go up, left, A, and then you go left, A. Well, it's still the same number of movements. And as long as they're clumped, the problem is we're not adding any more clumping. Clumping is the only thing I know of that reduces the number of movements. And we can't, like, I was hoping that going up to 5, going up and then left to 5, and then going left to 4 introduces clumping. But once you get to 5, um, you have to hit A. I mean, the code for the top layer itself. Um, up, left. Yeah. If your code was 354A, then it's up A, up left A, left A, then whatever path here. Right, right, down, down. Whether you do right, right, down, down, or down, down, right, right, going into this, you're still going right, um, then down, then back to A, or down, then right, and back to A. So there's some insight I'm missing about how these behave besides that. And I think one way to explore this insight is to go back to my part 1 code that was correct, maybe not. Yeah, let's make sure this is working again. And we're going to explore in here. So since we know this gives us a correct answer, let's do some exploration and find what those weird cases are so we can understand them. I started changing this, ruining. Was I using this? Full code min path. Yeah, we just started changing things in here. No keypad. So we had started refactoring this. Let me just fix it up real quick and we'll get it working so we can explore. I'm not gonna have that tutu here. We're just gonna check them all and search for minimums. So we still have all these options. Are we back to having this compile? Let's see. It's possible that VS Code has shit the bed. Invalid symbol format. We're just gonna restart our server real quick. And what's our plan once we get that up and running? We are going to explore. We could explore the full set of minimum paths for any given. Well, actually, that's a lot of them, isn't that? The Linux developer. Thank you for the follow. I'm using bastardized Linux here. I used to be an Arch, by the way, person, but I guess I could say I'm cured. WSL has been nice. I'll say that much. It's that's why I'm back on Windows, or it's why being back on Windows is tolerable enough. What happened? What do you mean? Like what happened with Linux and WSL, or here? Here, I'm currently fixing my original implementation because I know that's correct. I don't know why I didn't save it. Like make a commit. Still chugging. Yes, I'm still chugging. Oh, I deleted those, didn't I? I didn't just comment them. I started. I really started refactoring this. I didn't do a commit. Key code instructions. Okay. Well, this was instructions. We can recreate key code instructions from this. They were very similar. Okay. So we zip together our instructions to list map. Instead of our key paths, we use some key paths. So these should go back to working. If all other issues are fixed, we should see our ends one pop out here again. And if that's popping up, then we're gonna start doing some exploration. You can't ever imagine going back to Windows by choice. Yeah, I get it. I get it. But there were a few bits of it started off subtle. Like there are a few bits of tooling I want to use, right? So I like dual boot. Um And then, like you start spending more time in Windows, like maybe you get a game or something. Uh, and then like you buy some hardware without like shopping properly, making sure like you can run it with open source stuff. So like for my stream in particular, I am I've bought hardware that is locked to Windows. Um, and in the meantime, because you've like started playing with WSL, you're like, oh, well, this is kind of fun to play with. This is tolerable. And because it's tolerable, you spend more time there and you spend time enough to get yourself locked into friggin' Windows only software. So I have a few pieces of software and hardware. And yeah, I'm stuck. I'm stuck. Yeah, I did spend a lot of time like fixing my computer. But on the other hand, like you could fix it. When something goes wrong in Windows, I don't know what to fix, right? Like sometimes in Arch, it's your own fault. Yeah, I do use yeah, that that works just fine. When I first started my stream, um, I would use Emacs and then running it through the Windows server. So I was still using like my original Emacs setup. But now because of Scala 3, when Scala 3 came out, I was like an early adopter and there's only VS Code. And now that put me into VS Code. I think the Emacs implementation is catching up. I haven't gone back to it in a while. So I've become a normie. But you know what? At least Scala is not as much of a normie language. There you go. Yeah, but I mean with dual boot, you can't hibernate when you dual boot, right? So if you start working a lot and you have like a lot of context stuff that you want to save, and then you want to do the other thing, you're kind of stuck. Um, you have to figure out how to save your context. I mean, unless you can hibernate for a dual boot, but I feel like it's not unsafe. Scala's the last stronghold. Okay. See me next week when I'm writing in Java because I had to for work or something. I need to buckle down and do like Idris or Unison, get my hipster status back. Okay. Lap map is not a member point, so paths. Paths is just a single point. What happened here? The intent here is to get a list of paths. Wait, we were doing this whole thing. This should be a list of paths. Or I guess a list of paths in this case with a list of points. Next is not a member of. Oh no, this is a list of states. So we had a starting state. Okay, that's fixed there. What else? I don't know why I didn't save this. Idris is pretty cool. Um, have you looked at Unison though? It's kind of mind bending. I'll bring it up another time. From Dirk, so zero key zero is not found. Um, as from two and dir keypad. No, this should be using the num keypad. Okay. Are we back up and running yet? The worksheet is thinking to evaluate, so that makes me think we are back up and running. Okay. Okay, everything works again. This is our original answer, 20274. And honestly, maybe we could just do a memorize in here. Right? Let's just memorize our original answer, and maybe that'll do it. I got excited about that grouping thing. I'll have to do some exploratory programming later to understand what else makes it shorter. Clearly, there's more to the case than just the grouping. Okay, let's mirror these in a similar way. So on our right, we'll have our new implementation, which had kind of a nice clean ending to it. 21, part 2. Okay. Okay, this is a good way to compute this. We had a numpath length. We're just going to re-implement this in terms of the thing that returns multiple paths. Yeah. Well, comment out this original ends one. Let's move that down, pretend there's no garbage in here. Okay, and we're gonna implement this numpath length. Now, their path length is gonna be like minimum length. And this is what a memo is. Let's get that memo as well. At a certain depth. Okay, we're memoizing at a certain depth. Okay, Durkee path no longer exists. It's now Durkee paths. From the two dot min by length dot length. Okay, that only happens at the base case level, and even then, this could be memoized. So I'm not too worried. So now, Durkee path. We have a path. We have multiple paths. So we're going to do dot map and then paths in here now. We can indent everything that's in there. And then after taking the sum inside, we take the minimum of all those paths. Right. Yeah. It might not be sum though. Well, this is the sum of the minimum at each pair. So we don't have to like choose between anything. So we'll do that. So Durkee paths. And here it's going to be, we have to use numkey paths, but what happens? Now we have multiple paths and we choose the lowest. So numkey paths of whatever our key is, right? Our tuple. And then dot min. Dot min by length. Right. Okay, that should do it. Okay, and now it's thinking 218498 when we iterated just once. Oh, maybe there's something wrong with our recursion. Because, okay, this bit was giving us the right answer. What was our answer for part 1? 202,274. How are we getting a new wrong answer? Hey, we found a new way to get the wrong answer. So is there something wrong with this? How is this different from my previous algorithm? Aside from the fact, so Antoine was using this full code min path 3 deep. Where is that implemented? Much lower down here. It should actually be 2 deep. But is this the same? Is this the same idea? Zip path, and then this gets our. We are doing the same kind of thing, right? We're doing the sum min, and at the base case, I'm persistent. I'm persistent. uh, my lunch. My lunch is breakfast time. I had my midnight snack. Actually, still have midnight snack. Eating is good. Sleeping is good. I think you can increase your time by an order of magnitude. Mm. Alrighty. Um, so on the right, I have the implementation that works. On the left, I had what I thought was the same thing. So at a depth of 0L, Dermin path, just take map length. Oh, whoops, not dot length here. Map length dot min, or min by length dot length. They're equivalent, but I'm gonna make it the same anyway because I know the one on the right works. Map dot length dot min. Okay. So that's the base case, and in a recursive case, so like here, Durkee paths. We have our from to, we map our path, we prepend the phantom A because it has to start from there. And for from to, we then recurse. Where recursing when it's 1 means to go to the 0 case, which is here. So this is the 1 case, right? I skipped. I was the number of robots. I struggle to wrap my head around for some reason. And this is the same thing, right? So, well, I guess at this level, it's num key paths. But this recurses as many times as you need, which, for our case, is going to be 1. So we skip to the 1. And this min path 3 deep, I guess, would correspond to our numpath length. Yeah, numpath keys. Or num key paths. And we do our from to. Right, maybe we take out this map. Well, let's see where this is used. So I'm going to split that screen and keep min path 3. There we go. So we'll look at the place where min path is used. Min path 3 deep. Where was it used? Okay, the full code min path. The reason I scrapped this worksheet is because of all this jumping around. You can tell how scrambled my brain is by how scrambled my code is. So at this level, we do wait, what's this path? Okay, so we get this path by prepending the A zip code. Yeah, zip the code together. And here we map into min path 3 deep, right? So this here is essentially the min path 3 deep. So I'm going to restructure it so it looks more like it. So we have a from and a to. And inside that from and a to, we have a num key paths for our from to to. And here we did a map into the recursive case, and then sum. But up here, what are we doing? We're getting like the min by length. The recursive case should already get it for us. I guess this is a path that we're passing here. This is actually multiple paths now. All right. So we take A plus a given path, zip path, map, sum. Okay, right. So we're going to indent that because we're going to take the sum of it. So the outer layer is this bit here. Map case. We have the from and to, and from here we go into the min paths 3 deep, which is this. Oh. I mean, that's not pretty. So this is the min path 3 deep portion. This already exists elsewhere. So we can just do we could probably just do dir path length. Skip straight to it. But right, after we do this map, we have a dot min. And that makes this match this case. So after we do the what a way to refactor. So in the min 3 deep, we take our number of key paths. We take our list of num key paths. So that's here. We don't have a single path anymore. Yeah, let's just restructure this all together. So we have we zip map into that new function, and then we sum. And this new function takes a from and a to. And given that from N2, we do have to do all the paths. So we'll do num key paths for that from to and then map each of those paths. We don't need that there. So for each of those paths, we then do this thing, which is really just a recursive call that we can handle in a different way. And we take the min of that. Yikes, look at this nesting. Okay, I mean, I think that compiles. Okay, so we're back to getting the correct answer, 202274, right? Now, if 1 corresponds to 3, I don't know how many bots we need. So in the first case, how many robots were there? So you had, actually it's easier to see in here, where we worked through some examples. Okay, so yeah, suppose you're hitting 0. The first robot does this. The second robot does this layer. And the third robot does that layer. So there are 3 robots in total, but the way they count this, one that you're using, 25 that robots are using. Oh, wait. So one numeric keypad on the door that a robot is using. So we have one numeric keypad. We're going to input a 0. And then in this case, this is also a robot. So robot. No, that last one is not a robot. That last one is us. One keypad that you were using, 25 directional that robots are using. So they're only, if we are using this one, this is the one keypad you're using, or one directional. So this is dir me. Num robot. And then there are 2 of them. So there are 2 dir robot. Okay. So this first case was actually 2 robots using this. Okay. So, and we're off by 1, so just write 1. But when you have 25 robots are using directional pads, here replace 24. Okay, that's probably it. If that memo is good enough. Okay. I'll copy that worksheet output. There's a 24 here. Okay, I mean, all I had to do was memorize it. Memorize it and it's fine. But this is what happens when you're when you're tired. Like, I was so disorganized, like thinking about my recursion. I was like, let's just re-implement everything. This here, We still need to like not do that recursion manually. Um, okay, but we got it. We got it. So our one solution is fine. We just need to do a memo. And for the part two, or like this attempt at optimizing it, I abandoned doing the memo because I thought all you needed to do was make these grouped, so I didn't have to search everything. I guess it wouldn't be much of a problem if you didn't have to search everything. What time is it where I am? It is 7 a.m. Ah, okay. This this could use some cleanup, but should I clean up right now while it's fresh in my head while I'm up before I crash? Jesus Christ. You know why I wear these red glasses? It's so you don't see how bloodshot my eyes are from all the lack of sleep. I'm hiding my blood. Do I even want to see how I did today? Oh, wait. 2024. What? 3,000? All right. Well, I'm 3,000 because I'm persistent. Uh, I even made time on a delta. I mean, if all I had to do was memorize, I would have figured like lots of people would have made time on me. I would have figured my part two rank would be a lot lower, or a lot higher than my part one. I do love the orange sunsets. That is true. Um, but there are two reasons. There are three reasons actually. These lights here, I have lights on me when I have the camera on, and they're super bright. I like how everything looks in them. They're really fun to wear, and my eyes are bloodshot. When I went for a bathroom break, I took these off, and I was like, get some sleep. Um, okay, let's at least fix this recursion here. Let's unmanually recurse that. That way we drop her off by one. Um, I'll use my right hand side here as a model. Um, and then we'll look for people who are sane and chose to wake up to do app in the code. Um, okay, so in this case, we pass along the depth. I think we can go straight to doing this dir path length. Because dir path length, well, okay, uses the dir path keys. Yeah, that's the problem, is okay, that is not part of the same recursion. Well, no, this is the same recursion. We're just kind of recursing it at the wrong level. Well, okay, this starts at dir key paths and recurses with dir path length. There's some common structure here I can remove. Um, we want to do this one less time. So, I mean, what if we passed in like all the paths that we were doing, like all of the from twos that we were doing? this part right here, right? This part right here is the same. That should probably be a function in itself, right? Given a path, what's the fastest way to get there? Like their path length should probably just be going from a path. Um, there's a thought. Mm, So we take these and then we map the function that takes a path. Yeah, that's that's reasonable. So we're gonna invert the order in which we do these, and then we won't have to do this, I suppose. Well, okay, num path length. Oh, I mean that's a main difference there. Like num path length is actually using a full code. Num path length was the one that was written sanely. This dir path length should also take a string. So we'll have a path. Okay. So we need to take our path. This bit becomes the first part of our code. Put it inside our calc. Oh, hold up though. I think this is why we memorize at this level. Well, let's see. I think there might still be a way to refactor this. So we're gonna do this. And this is the old dir path length definition. So this is at the point at which we do this if else, right? Depth equals 0, then we do that. Otherwise, we do this bit minus the nested. So otherwise we do that and we just map your path length of that path and depth minus 1. Okay. But this is also the point at which you can find the we can do the memo. So lazy val recurse. So we actually recurse by doing this. No, we do that inside. So we're gonna map and this is a tuple. Two. Okay, so we have from to and then the depth minus 1. Oh no, this is the point at which we memoize in here. Yeah, this is the point at which we check the memo. So lazy val curse. key paths. This is a list of string. Oh, right, these are strings. So we take this path, right? Um, hey, wait a second. Okay, so we inverted this. We go here first, and then in this from to, we do the old dir path length, which starts with this if else, and then maps from this into what is now just the recursion. So this path, like the recursive version of this, where we fully calculate, is just dir path length. I know we wrote this a second ago, but depth -1. Okay, and at what point do we take advantage of the memo? Well, when we had this from to. So when we had this from to, we can use the memo. Okay. This whole thing is the recurse. Or we could say this is. So lazy val recurse. I know I'm going in circles. And then this is where we do our getter else, so memo dot getter else update. With our from and to and depth -1 actually. And otherwise we do our recursion. Okay, so that version should work. Let's just comment out the old one. Check that that compiles. So dir path length now operates on paths. So we can delete this and just do dir path length. Pass in that depth. All right. We still want to get min here. Let's see what's going on here. We have our path. Oh, right. We just need to move these parameters inside. And this is a triple that we're passing in. Int or long. So at some point we're returning ints. Memo get else update. Curse should return a long. Oh, what is this? Dir key paths from to, and for each of those. Wait. Yeah, this gives us paths. For each of those, we get the length and we get the min. Chris is a long. This memo getter else update gives us a long. And then this, we're intending to map that into a list of longs and then sum them up. I don't know where that int came from, but there, at least we're getting the right answer. Oh, look at the calendar. It's getting colorful. Okay, so now this looks a bit more similar. It's kind of weird to me to have the memo be in so deep. Um, and this number still, it's still one short of the number of bots. Because what it is, well, 25 bots are using keypads. I mean, if I set this to 0, that means one bot is still using a keypad. So we're kind of still assuming that at least one bot is using a keypad. And I guess that's happening in here. We should be looking at the depth in here as well. Yeah, like in this case, if depth equals 0, then we're just doing this and getting its length. Map length.min. Otherwise, we recurse. We shouldn't always just go straight to recursing. Okay, now this will work when I put in 25. Um, wait a second, wait a second. No, no, not quite. What does this even, so if our recursion depth is 0, we have 0 bots, we shouldn't be doing this at all. We should just do, so this requires a minimum of 1 depth. Right, because something has to calculate that path. I guess path.string or path.length would be that case. Path.length. Okay, and we've introduced an issue here. We have an interlong dot min dot too long, I guess. Numkeep has. Yeah, we get the length. Okay, so that should do it. Nope. Uh, so, I mean, if this is our number, then we assume there's always one numeric keypad that a robot is using. So we don't have this thing going on here, right? Um, did I forget to commit again? Yeah, I'm not gonna try and refactor everything else because clearly I can't keep track of state in my head. I can't keep track of the code. Depth is 0L. Let's get this to, well, this is compiling. So at 0L we do that. Otherwise we go into a recursive case where yeah, we check depth -1. Well, we get the minimum of all the depth -1 calls. So this here should just be depth. So if you go back to part one, which we have two bots using numeric pads, then let's see what answer we get. Hey, hey there. I am done. I'm done. I'm just refactoring a little. So let's say there's only one bot. These numbers are too long. Where was I? Okay. Before we mess things up too much, I'm gonna revert back to where things were working. I'm actually gonna commit things, and then we'll save a refactor for another time when we've had sleep and time to think about things. Yeah, I shouldn't be. I think that code we did want. Nope, nope, nope. We still need to get to the point where. Okay. This is our attempt at refactoring, which we're going to comment out. We're just going to leave a mess in the repo. We clean up another time. And this is the thing that works. From to, this takes a from character and a to character. You're going to give part one a little more time. Oh no, I'm done with part one and two. Yeah. I mean, part two is just part one memoized, so it's not too big a jump. As long as you structure it in such a way. Great, great. We're back to working. That's it. That's my code. Uh, yeah, to go from part one to part two. Um, I think even for part one, I went directly to calculating lengths instead of just constructing the strings. And for part two, all I need to change was to add a memo. So I could have saved myself 3 hours by just doing that, yeah. Cube Gamer 33, thank you for the follow. By the way, for those of you still around, we're gonna take a look at the leaderboard. There's a leaderboard if you'd like to join. Where is it? Yeah, I've been pretty much right at eighth all season. So you've got some fast people in here. I think Alexander has pointed globally, as well as um, I think Zara has too, but they are not in here. Oh, we have a handful. Oh, right, Arrow pointed. And Akari, I don't know if you're still around, but Akari was here in chat, and Akari's pretty fast too. So let's see who else is being crazy. Um, oh no, is it just me? uh, Michael, you're calling a night soon. We could see how Michael's in for part one. Uh, I'm. Let me just see what Gore's doing here. This is gonna go. I've never met Gore, but maybe today is not the day. All right. Michael. Michael here from our chat. Let's see how we're doing. Oh, smart coder's in here too. And Izzy. Cool. I'll clean this up another time. I'll probably clean up offline, in which case, if you're curious how that cleans up, that's where my solution will be. And we run a raid. You think day 21 will be your limit? It could get easier. It could get easier again. All right. Well, I would say good night, but it's clearly morning now. You can see the sun's coming out the window. This is the latest I've stayed up. So thanks for sticking with me through this. I can't even talk. My eyes are bloodshot. Gotta sleep.